the content is going to be there. Module number one, people. Module number one is the introductory part. Okay, we're going to be talking a little bit about some of the basic concepts of networking. Yes, Nikhil, you have a question.
Yes, one quick question. How we can mark attendance for this course? Is there any link for attendance or it will
Nope,
be marked automatically?
it's going to be automatically just by joining the class. It will be automatically checked. So don't worry.
Thank you.
Yeah, you're welcome. Okay, so we're going to be talking about these basic concepts. Well, we say basics, but it's not because they are really basic, but because we just need to know how these things work in the cloud. Okay, so before we formally start talking about all these things, let me just talk a little bit about how was my environment when I was at the bank. So you are going to see that it's not that different. Okay, many people is kind of scared when we talk about the cloud. Okay, for some people is so fuzzy. Okay, or it looks like it's something unreachable or something from other world, right? But it is not the case. Okay, the cloud is the same thing as we have been working since I have memory. Okay, it's the exact same thing. So let me just bring a couple of ideas so you can see that it's almost the same when we start talking about all these kind of things. So let me write something up here. If people, if you don't see my ink, okay, while I'm writing down here in the whiteboard, if you don't see the ink because you have any visual impairment or something like that, let us know. Okay, I can change the ink at any time. So I normally write in blue. Okay, but if you don't see that color, let us know, and then I can change that color to another one. So how was my environment, people, when I was at the bank? Okay, let me just put something like this. Okay, imagine that this is one building. Let's say this is building number one. Okay, and let's say that this is my headquarters, right? And of course they are connected, right? They were connected by optical fiber. Okay, optical fiber, and okay, and of course, let's say that here was our users, right? And over here we have our data center. Just put it like this. Okay, this is the DC data center. Okay, and these were all our users, and of course we have the different floors, right? Each of them were in a different floor. So this is floor number one, floor number two, floor number three. Okay. Why I'm telling you this? Well, because we normally in the data center, of course, we have our servers, right? So let's say that this is our servers, server number one, whatever. Okay. And then we have our switches over here, right? And well, let's say that this is our core switch. Let's say that is our core switch. All of them are, of course, connected with optical fiber. Okay, and then we have switches over here, right? In something that and we normally call this the IDF, right? If you remember, we have IDF. Okay, talking about a little bit networking, right? So IDF, we call this the MDF, right? IDF. Let's say IDF 1, IDF 2. 2 and 3, they all are connected over here, right? Maybe, and then they go here over optical fiber to connect to the core switch. Okay, so that's the way it works, right? And then you connect, of course, here the servers to the servers switch, right? So this is the server switch. They are connected to the core switch, and then all of it. But that was easy peasy. But then we have offices. Okay, we have other offices over here, maybe in other city, right? In my case, these were in Mexico City. Okay, in my case, but we have other offices in some of the main cities. We call them Guadalajara. Okay, for the ones that knows a little bit about Mexico. Well, we have offices in Guadalajara, but not only that. Okay, we have here, we have the cloud. In this case, we're Azure, but we also have offices where in UK. Okay, so for the one that is in UK, we have offices in Leeds. Okay, so maybe not all of you are going to know what I'm talking about, but for the one that is in UK, well, we have offices in Leeds. Okay, but not only that, some of you mentioned that that you are in India. Well, we work with a lot of people from, and let me just tell the name, we work with a lot of people from HCL. Okay, the ones that are in India, they know what I'm talking about. Okay, so we have a lot of people from India, for of course from Bangalore. Okay, with HCL. Okay, and we have some other small offices over here. Let me just pull them over here, like small offices. Okay, in other cities. So how can we connect all of these guys? Well, of course, we have here, we connect all of these, okay, with something that we call, and okay, MPLS circuit. Okay, so we have an MPLS connecting our offices from so from Mexico City to Guadalajara in Mexico. This is Mexico. Okay, but then connected to sorry, HCL was not over the MPLS. HCL was in a different way. Okay, so we have this MPLS circuit over here. Okay, all these was MPLS. Okay, and then these offices we connect them. Okay, with to be honest, I don't remember if it was an E1 or a T1, but well, we connect this with a VPN, right? A VPN connection. I don't remember it was E1 or T1, but we have MPLS with these offices and E1 T1 with a VPN on this other side. And then for the small ones, okay, we brought here Azure into the equation, okay, also with the MPLS. We're going to talk about all these, okay, but then how can we connect these small, okay, some small offices over here? Well, we connect them, okay, with a VPN, but this one, instead of being an E1 or T1, these were small offices that they don't have that infrastructure. So we connect them over ADSL. ADSL. Okay. So that was my environment. So you can see we have ADLS connectivity with a VPN. We have E1s and T1s over a VPN. We have MPLS connectivity where we connect Azure with our MPLS and all those kind of things, right? So we are going to be talking about all this stuff. Plus, what else? Of course, we have over here, okay, because our users they want to go out to the internet, okay, to the internet. So we have, okay, you normally have a proxy server, right, that works as a NAT, right? We're going to talk about NAT gateway here. What else in terms of security? Well, I work all these, okay, when I was at the bank. Of course, all these were Cisco. Well, let me tell you something. When we started working, okay, when I first joined the bank, okay, we used to work with Tricom. I don't know if any of you remember Tricom, but that was our vendor, okay, Tricom. Uh, okay, so but then we switched to Cisco. So we have Cisco switches. We work with ICE, okay, Cisco ICE. In terms of security, we work with Checkpoint. Okay, we work with Checkpoint. We're going to be talking about firewalls here. Okay, on the last day we talk about security. So we work with Checkpoint instead of working with Cisco ASA. We work with Checkpoint for whatever reason. Well, we decided to go that way. Uh, we're going to talk about, of course, we have here applications that our people in or the offices all around the world, they need to access to our applications, right? Especially our core banking. So we work with an A10 load balancer. This is a load balancer. We work with an A10, but we also work with F5s, okay, load balancers. And and when we work with this brand with Tricom, we used to work to protect our infrastructure. We use Ironport. I don't know if any of you remember Ironport, but we used to work with Ironport. So a lot of networking stuff over here, right? So why I'm bringing you these people? Because again, I want you to remember this diagram, and we're gonna come back to this diagram because we are gonna be mapping all the things that we're gonna cover here in this class in Azure networking. We're gonna be mapping all these to our on-premises environment. So you are gonna see that is nothing different. And by the way, for the ones that are locally in Mexico, I also have a hoster. Okay, in that case, we work with Kio Networks. Okay, I don't know if any of you, again, for the ones that are local in Mexico, this is our hoster. Okay, for the ones that are not familiar with Mexico, Kio Networks is like Rackspace. Okay, like here in the States we have Rackspace. Well, in Mexico we call it Kio Networks. That is the hoster. So we used to work with Kio Networks, and we brought them also with an MPLS. So everything was connected with our MPLS except for our offices in that we connect over ADLS, and the offices, the connectivity that we have with HCL in India, that we connect them with. I don't remember if it was a E1 or T1, but whatever, it was a VPN. Okay. So questions, people. Questions so far. I mean, this is my diagram of what I used to work when I was at the bank, but I don't know if you have any questions. We are gonna be talking about every thing. Okay, everything that I draw here, we're gonna be mapping it to our class. Okay, questions, comments, anything? Nope. Good. Good so far. Okay, so let's talk a little bit about virtual networks. Okay, of course, as I mentioned, okay, virtual networks are the same thing. Okay, it's like in my diagram, I have a server. Okay, and that server may be hosting my applications. In this case, my core banking or my web um, my web server or whatever other thing. Okay, so I have a server, right, that is living or running in a virtual machine. Okay, and it can be a Hyper-V virtual machine, it can be a VMware virtual machine. Okay, or it can be a physical server. Maybe it's not a virtual machine, it's just a physical server running something. Okay, so you have that virtual machine or that server, right? Of course, in a large organization, well, you are not going to have only one server, you are going to have multiple servers. Okay, for example, in this case, running your database, maybe this is your SQL servers, and you need to balance the load. So for that, you are going to have an internal load balancer. We're going to talk about this internal load balancer to distribute the requests among your different virtual machines or physical servers, in this case for SQL Server, right? So this is your backend, but you also have your front end, which are that are your web servers. Okay, and that is more common. You have here again, it can be a virtual machine, it can be a web application, an app services or something, and you need to have a load balancer. Here is when you can bring the F5 or the A10 or whatever other load balancer you want, right, to receive the request from the internet, right? Most of the time, well, it can be port 80, which is not recommended, but port 443, which is HTTPS, right? So you want to receive all the requests with HTTPS in your load balancer, And why I'm telling you this? Well, because it's important that your load balancer supports HTTPS, right? So you receive those requests on your load balancer, and this one is going to distribute the request. It can be a round robin, or it can be you can have a specific path. For example, you can have this path affinity. Okay, there are different things. We're going to talk about all these load balancer topics in our next module. Well, in module number 4 and 5. So this is something that we used to work in the on-premises environment, right? Again, maybe these were Hyper-V servers. Maybe they were VMware, right? VMware or whatever other thing. Okay, these are your virtual machines. Well, we migrate these to Azure. Okay, we migrate these virtual machines to the cloud, and now we're going to see how to work and how to protect everything. So as you can see, it's nothing different. Okay, it's almost the same thing. You want to communicate to the internet. Okay, because well, you want to communicate to the internet inbound for inbound, but also for outbound. Okay, we're going to talk about that. Okay, because well, you have your core banking, your or whatever application you have. Okay, and that is going to receive requests. Okay, but also you have users that they want to go out to the internet because they need to consume some software as a service applications like Office 365, Salesforce, whatever software as a service, ServiceNow, whatever. Okay, so you have software as a service applications that your users need to go out. Okay, so you have not only inbound traffic, inbound requests, but you have also outbound traffic. So you need to know how to communicate, okay, in a better way and in a secure way to the internet. So we're going to talk about that. You have resources. How can you communicate your front end servers with your back end servers? Okay, how is the best way to communicate them? How is the best way to protect or align them? Okay, making an analogy again with your own premises. People, we normally separate these two environments, and maybe this was one switch. Okay, so maybe it was switch number one, right? While this was switch number two, maybe. So physically, we separate the front end from the back end. And maybe not only that, I remember that we used to work with VLANs, right? So maybe again, this is VLAN number one, maybe this is VLAN number two, right? Or whatever number of VLANs. Okay, so you can either separate them physically with different switches, right? Or if they are all in the same switch, well, you separate them at least with VLANs, right? And then you have the voice over IP VLAN, you have the users VLAN, you have the servers, front end servers VLAN. So you have different VLANs, and then well, you need to work with your routing. We're going to talk about routing also here. So you need to work with your routing part so you can communicate your VLANs or you can communicate your switches between them, okay, in a secure way. So you don't have you have these segments because you don't want to have all these multicast and broadcast domain, right? So you want to have these VLANs so you can narrow the broadcast in your network. Okay, so that is the main reason of this part. So how can you do all these things that we are used to work with them in the on-premises environment? How can we work them in the cloud? Well, we're going to see that part. Of course, you're going to have a hybrid environment. Okay, maybe, and I have done this with customers. So maybe this part, okay, all this part is going to be in Azure. Okay, all this is going to be in Azure, but this part, okay, all this over here is going to be in on-premises. Okay, so and I have done that part with some customers that they cannot publish their databases to the cloud, even if it is a private environment in Azure. Okay, they are not allowed to upload or to migrate their databases to the cloud. Legal implications, some compliance things. Okay, they cannot move their databases to the cloud. They need to keep that databases on premises, but they want to publish their web applications, their front end web applications to the cloud. So we migrated the front end to the cloud in Azure, but keeping the databases on premises. So in that case, we need to connect. We need to have this hybrid environment to connect the web applications to the SQL databases on premises in a secure way, in a fast way, improving performance and all those kind of things. Okay. So you need to filter your traffic and you need to work with routing. So you can see, people, that all that concepts, all that topics that we are used to work with them in an on-premises environment, they are exactly the same in the cloud with small changes because, well, we need to adapt to the cloud with small changes. We're going to talk about them in a moment, but at the end, you're going to see that is the same thing. So in other words, you don't need to learn a new language. Okay. If you speak the networking language, you are good to go. You don't need to speak a new language. You don't need to learn a new language. You just need to adjust or adapt that language to the specific environment, in this case to the cloud. But the language is the same, the concepts are the same. Okay, that said, people, as promised, we have 1 hour talking here. So now we are going to take the first break, and this is a short break. Okay, it's gonna be only 5 minutes break because, well, we haven't talked that much here. So we're gonna take a 5 minutes break, just enough to come back. Okay, refill our coffee and come back so we can keep the discussion going. So only 5 minutes break. Let me put that timer here so all of you know that you need. Yep. Give us a thumbs up here in the Teams so we can know that you are back and we can continue. Yep. Okay. Very good. So let's continue talking about this part. So now we can see that everything is going to be connected, right? So we have virtual machines, we have load balancers, they need to be connected to the internet, we can have internal load balance and so on and so forth. But at the end, okay, when you connect something to the let's say in order to connect something to the cloud, what is the normal let's say that the normal infrastructure that we normally have in our own premises? Again, let me just bring here a very quick diagram for everyone. So we normally have, oh, let me just switch the color here to blue. Okay, so we normally have something like this. Okay, so we have our server. So let's say this is going to be server number 1, right? It can be either a Windows or Linux or whatever server. Okay, so server number 1, we normally connect this server, right? We connect this server to a switch, right? It's going to be switch number 1 again. You just write it correctly. Switch number 1, right? But we want this server to be connected to the internet. Let's say that this is hosting our web server. Imagine that this is our web server, right? So this is going to be connected to the switch. Okay, the switch is going to be connected to a router most of the times, to a router. Okay, and the router is going to be connected to the internet. Okay, so this is the internet. Correct? Sorry about my drawings. Okay, I'm a technical guy. I'm not a graphic designer or something like that. So my drawings are awful. I know. Okay, but with a lot of imagination, people, you can understand my drawings. Okay, so why I'm telling you this, guys? Well, because we normally let's put this as a flat. Okay, let's say that this is gonna be a flat switch. Okay, and let's say that this switch is gonna be, let's say that it's gonna be that 10.0.0. Let's say dot zero, and we can say that is gonna be a /24, for example, right? /24. So in that case, okay, let's say that this is gonna be the server is gonna have the 10.0.0.1, okay, dot one, with a subnet mask. This is the IP address with a subnet mask of 255, 255, 255, dot zero. Okay, this is the subnet mask, right? And then let's say that the router is going to be the 10.0.0.250, 254 most of the times, 254, correct? So when you have these space range, okay, when you have this space range, what this means is that you have 255, okay, IP addresses, right? So you can go from one, okay, from 1 to 254, right? From IP address 1 to 254. So in this case, the 254 is our router, the number 1 is our server, right? So this is this one and this is that one. This is in an on-premises environment, okay? And again, having a flat switch with no VLANs, not nothing, okay? Just a small switch connecting your things here together. And so you have an IP address of 10.0.0.0.1 with a subnet mask of 3 octets, or 255, 255, 250, and the default gateway, okay? The default gateway, which is the way that this server has to get to the internet, is gonna be the 10.0.0.54 254. Okay, this is the default gateway, right? Is the way that we know this server has this IP address with this subnet mask, okay? Because we don't have any subnets in this case. It's just a big subnet, uh, just one single subnet with this default gateway. So the default gateway is going to tell the server where to go, okay, in order to get to the internet, right? And well, it can get more complex, right? We can have other routes, if we have VPNs, etc., etc. But just to keep it simple, this is the way that we normally work in an on-premises environment, correct? Well, in the cloud, people, it's a little bit different, okay? In the cloud, let's say that, let me just divide this here. Let me just change the color of my ink, because we're gonna be working, let's say, more maybe the same things. Okay, we have a server, and let's say that this is gonna be server number 2. Okay, it's the same, it's a web server. Then we are not gonna have a switch. Okay, what we are going to have is a VNet. Just making the analogy with the on-premises. Okay, so we don't call it a switch, we call it a VNet, right? And if I go back, let me just go back a little bit here. I don't have any subnet mask. Sorry, I don't have any subnet. So okay, so because I have the 3 octets, which is 255, 255, 255, so we only have one subnet number 1, okay, which is gonna take the whole thing, right? So in that case, gateway IP means router IP. Gateway. The default gateway is the IP address of the router, because that is the way that your server is gonna go out to the internet. So in this case, guys, so we don't have switches, we have VNets, okay? And in the VNet we have subnets. You can have one or multiple subnets. Let me put it here, subnets. But you must have at least one subnet, okay? So let me put here. So you must have at least one subnet. You cannot have a VNet without a subnet. You cannot have. Okay. You can have a VNet with multiple subnets. Yeah, that's possible. You can have a VNet with multiple subnets. Um, so for example, in this case, I can have a 10.0.0.0, and I can do a /16, for example. Okay. I can do a /16. This is for my VNet, okay? This is for my VNet. And for the subnet, okay, for the subnet, I can do a 10.0.0.0/24. So in this case, this is the one, the subnet is the one that will have the 255 IP addresses, okay, the subnet, and the VNet is going to have all these IP addresses, which is like, if I remember, it's like around 16Ks, okay, IP addresses. It's a lot, okay? So that is the way it works. And then, okay, and then you don't have, okay, well, you can, if you want, you can have a route server, but most of the times you don't need it, okay? So I'm not gonna put this here, the route server, but you need a router, right? So in the cloud, you have a router, but you don't need to manage it. You don't need to deal with that router. The router is automatically assigned for you. And then you have the internet. Okay? This is the internet. So why I'm telling you these people? Well, because in Azure, there are some IP addresses that are going to be reserved. So in the on-premises, you can go from 1 to 254 IP addresses. You can use the whole IP address range. In the cloud, is not the case. Okay. In the cloud, the first IP address that you can use is IP4. So it's going to be 10.10.4. If you have a DHCP, okay, if you have a DHCP in the cloud, okay, a dynamic IP address assignation, the first IP address that you are going to get is IP4. Why we don't get IP1? Because, well, in the on-premises, the first IP address available is number 1. Well, in the cloud, you don't get number 1 because number 1 is reserved. Okay. So the first, and this is important for your exam people, the first IP addresses, so IP1 to 3, okay, IP1, 2, and 3, they are reserved. Okay. Please remember this for your exam. So the very first IP address that you are going to get is IP4. Okay. So let me just bring that as this slide to explain a little bit better. Okay, so that's why I prefer drawing a little bit, because if I just show this slide for you, it's like, oh, this is a lot, but no, it is not. Okay, look at this IP addresses that are reserved. Of course, 0, because that is the network address, that is the address space range. You never use IP0. You cannot use IP0. IP number 1, okay, is the default gateway. Okay, is the default gateway IP number 1. In our drawing, it was 254, right? In our drawing. Well, in Azure, the first IP address, which is IP1, is reserved for the default gateway. And then IP2 and 3, they are reserved by the internal DNS. You can have your own DNS. We're going to talk about this in a moment. You can have your own DNS services. But in Azure, by default, we have a DNS. So IP2 and IP3, they are reserved for the DNS. So that's why the first 3 IP addresses, 1, 2, and 3, they are reserved. You cannot use them. Plus, of course, IP0, you never use it, and the IP255 that you can't also, okay, you cannot use it in the on-premises because that is the broadcast address, right? So this is the same, okay? IP0 and IP255, you cannot use them even in the on-premises environment. But the new thing is that IP1, 2, and 3 are reserved, so you cannot use them in the cloud in Azure. More than that, people, is exactly the same. Okay, you can have a network class A, B, or C. Okay, which is a 10.0.0.0. Okay, or 172.16.0 or a 192.168. Okay, class A, B, or C networks. You can have them in the cloud. Okay? Now, we're not going to talk about here network design or architecture best practices, but we normally try to assign a small amount of IP addresses available in the cloud. Okay, you don't want to have 16,000 whatever number of IP addresses. Well, because it is more exposure. Okay, you have more security risk on that case. So how are you going to design your solution? Well, it depends, but we normally try to have as less IP addresses as possible. Okay, because well, we don't want to have that exposure. Okay. Some unavailable addresses, the multicast, the broadcast, the loopback. Okay, these are the same IP addresses that we never use in the on premises, right? For example, the 127 is the local host, right? So these are the ones that we don't use. Everything else is the same. Okay, everything else is the same. Just one important thing. Okay, especially when you want to have a hybrid environment, people. When you want to have a hybrid environment, be careful not to overlap. Okay, your networks, because I have seen people, some customers that they have, for example, the 192.168.1.0 in the on premises, right? And then they want to they want to have the same, let's say the same this is on premises, and this is Azure. Okay, you can have them. Okay, you can have them. Yes, you can have this address space range in both in the on premises and in Azure. You can have them, but the problem is when you want to connect, okay, your on premises with Azure, then that is not going to happen because you are overlapping your address space range, correct? So again, be careful on that part. Okay, be careful with overlapping. Try to use a different address space range for the cloud than the one that you have in the on premises, because that is a very common mistake that I found with our customers. More than that, more than that is exactly the same things. Okay, as I mentioned, you can have one VNet with multiple subnets, and in Azure in the cloud you cannot have a VNet without a subnet. You must have at least one subnet. That subnet can be the whole address space range if you want, but you must have a subnet in the cloud. Okay, let me just take a look at something else. What else? Okay, now, you know, people, that is it possible to extend to layer 2 from on-premises to the cloud? It is, Andy. It is possible. We're going to talk about that in the next module. Okay, well, in module number 3, but there's a possibility to have a layer 2. Yep. Mhm. Okay. Now, when you work in the cloud, okay, when you work in Azure, okay, you know that Azure works with regions, right? You know that Azure works with regions. So we have the East, West, Asia, Europe regions. Well, this is important because depending on the region that you pick, it's going to be not only the cost of your services, but also the connectivity that you may have. Okay, there are some services that they are local. Okay, let me repeat that again. When you work in Azure, you have regions, correct? And when you deploy something into Azure, that something is gonna always ask you for the region. For example, if you wanna create a VNet, it's gonna ask you in which region you wanna deploy that VNet. If you want to create a virtual machine, then it's gonna ask you where in the world you wanna place that virtual machine. Okay, and so on and so forth. So every time that you work in Azure, you are gonna be asked for a region. Okay, and there are some services that they are local to the region. So only they only work in that specific region. There are some services that they are, we call it geopolitical. For example, what is a geopolitical? Is that, for example, if you deploy something here in, let me bring my pen. If you deploy something here in the, let's say in the United States, for example, okay, well, the geopolitical region is Americas, right? And for Americas, I mean the whole continent, not only the US. But you deploy something in the US, for example, in the East US, right? Well, that is the region. The region is East US. Region is East US. But the geopolitical region is Americas, the whole America continent. Okay? So again, there are some services that they are local to the region, There are some services that they are local to the geopolitical region, and we have services that they are global. Okay, so they are global, so they can work with any and every region in the world. So that is why it's important the regions, because depending on the service that you deploy is going to be the region or the connectivity that is available for you to work with. So that's it. That is all about the networks. So now let me jump into into my environment to show you a couple of things. So let me just bring here my Azure environment. Okay. And for the ones that are new to Azure, for the ones that are not familiar with Azure, okay, let me just explain you this. What if we have a small subnet like that? We have to reserve the first for IP addresses. Yes, you still reserve the use. It doesn't matter the subnet mask. Okay, the first three IP addresses are reserved. Okay. So be careful when you work with a subnet 27, 28, 29, because then that is going to mean, okay, that means that you are going to have only one IP address available for you, or two or five IP addresses available. Okay, be careful on that part. And let me tell you something. We're gonna see that in some services like a virtual gateway or a firewall that require, okay, they require that you have a subnet with /27, for example. Okay, if you don't have a subnet with a /27, you cannot deploy that gateway or that firewall. Okay, there are some services that they must have a subnet with a /27, 28, or 29. It depends on the service. Okay, so let me just bring here a virtual network just to show you a little bit about the virtual networks. And let me just click on create virtual network. Okay, so you can see that by default it's going to ask you for the subscription. Okay, you need a subscription. It's going to ask you for the resource group, whatever that is, whatever resource group. You are going to give this a name. Okay, you're going to give this a name to this virtual network, and a region. Again, remember, the region is important because everything that you deploy in Azure is going to ask you for a region. Okay, so the region matters. And then look at this. When you move to the IP address, it's going to ask you, okay, well, by default, it's going to write you an IP address range. Okay, be careful on this part because this is by default. Azure is going to auto assign you an IP address range. Be careful. Maybe you don't want this IP address range. Maybe you need something else. And you can see the number of IP addresses that are available. In this case, you have 16. Well, you have a /16 of a subnet mask, but this is going to be a lot. Okay, so if you don't want look at this. This is going to give you 65,000 IP addresses because you are using a /16 subnet mask, right? So it's going to give you 65,000 IP addresses. It's a lot. And then, but this is your address space range. And then you can create a subnet, and you can see that by default is assigning you a subnet. This is the default with a /24. So this one is going to give you a 255 IP addresses minus the ones that are reserved. Okay. But you can create multiple subnets if you want. For example, if I want, I can delete this one. Okay, for example, I can remove that subnet, and you can see that a virtual network, okay, cannot be created without a subnet. I must have a subnet. So I can create one subnet here, and I can say, okay, it's going to be my 10.5.1.0/24, for example. Okay, and let me see, is 10.5.0. Sorry, this is the name. This is the name. Well, let's say subnet one. Okay, subnet one, and it's going to be 10.1, 10.5.0.0/24. So this is going to give us, look at this. It's going to give you that 255, but you can see that 5 of them are reserved. Okay, 5 IP addresses. We don't really reserve 5. Okay, we only reserve 3, but that .0, which is which is the address space range, and the 55, which is the broadcast, we don't use them. Okay, so you can see this here. Click, and then I can create another one. So it's going to be subnet 2. Okay, subnet 2, and I can say, okay, this is going to be the 10.5.2. Okay, dot 2. This is possible, people. This is possible because we have a /26. So we can divide these 65,000 IP addresses. We can divide them into multiple subnets. Okay, so be careful on your address space range, because if you want to have multiple subnets, you need to have enough IP addresses in your space range in order to subdivide it in multiple subnets. Okay, so be careful on this part. And then we have some security. We're going to talk about security later, and then you can review and create. And maybe I'm missing the name here. So let's say it's going to be JC VNet AZ700, whatever. Okay, there we go. And that is the way that you are going to create your VNet. Remember, a VNet is like your switch. Okay, making the analogy with a physical switch in the on premises. So that is the way that you create a VNet to assign it to whatever. Now, why do we want a VNet? Well, you can see here that I have multiple VNets in my environment, right? And look at this. For example, this VNet contains multiple subnets, right? Look at this gateway subnet. That this is the one that we're going to talk about. This we have a database subnet, public, shared, and you can see that we have in this case 4 subnets in one specific VNet, and the address space range of that VNet is this one, 10.20.0.0/16 with 65,000 IP addresses. Okay. Why do we need a VNet? Well, because if I go to a virtual machine, for example, and I try to create a virtual machine, I'm not gonna deploy a virtual machine right now, but when I create a virtual machine, it's gonna ask us for networking, right? It's gonna ask us for networking, and then you can assign that virtual network that you may have in your environment. Okay, so in a large organization, you normally have a network engineer that is the one that design and maintain, control and manage all your network, all your network stuff. So maybe you are not going to be allowed, maybe you don't have permissions to create a VNet, but someone, the network engineer, is going to create that VNet for you so you can use it in your environment. So that's why you are going to create those VNets, and then you can go ahead and bring them here. Say, oh, I'm going to pick this one. Okay. And then you can see this is the VNet that I'm using. And then I can bring the subnet. Okay. You can have multiple subnets. So I can bring the subnet where I want to deploy this virtual machine. For example, if I pick the East, let me go here, region. Let me pick the East US. East US. Okay, I'm gonna pick East US for this virtual machine. So when I go to the East US, then it's gonna show me my VNets. For example, this is the one that I show you, core, and then it's gonna show me the subnets that are available for me. Correct? These are the subnets. You can see that the gateway is not available because it's specifically for a gateway. Okay, but I can pick any of these ones. For example, maybe this is going to be a web server. I can put this one in the public web services VNet, and so on and so forth. Okay. Would you be able to add more IP address on existing VLAN? Yes, very good question, Suki. Yes, you can do that. Let me just show you that. It's a very good question. So I'm gonna go back to the virtual networks, and here on the existing, this is the existing network. I can go to an address space range, okay, and then I can add another address space range here, okay, if I want. I can add another space range to my VNet. So for example, this one can be, I don't know, that 10.80, for example, dot 0.0/16. Okay, And you can see that I am adding another address space range to my VNet, right? And then I can click save, and then this address space range is going to be available. So when I go, I can create a subnet that is going to use this address space range for me. Okay. So the answer is yes, you can do it. Uh, pa, pa, pa. Okay, is there a way to export all the VNets currently used under a subscription? To export it, no. I don't. I'm not gonna say the word export them, but you can go here and export that template. Okay, so here on the VNet, you can go to the template. This is gonna generate the JSON template that we use, and then well, you can export this template and then deploy the template in your other subscription. So that is the option. Correct? That makes sense. That is the way that you can do it. Okay, by exporting that template. This is the JSON template that we have, and then you can deploy it in another subscription that is gonna create that VNet for you in the other subscription. Good. What else do we have here? Some of you are asking, can I change the slash 16? Um, yes and no. Okay, you can change that later. Yes, but not if you have a subnet created. So you will need to delete the subnets first, then you can move the subnet mask and to whatever other number, and then you will need to recreate the subnets. So it's a little bit more complicated than just changing here the value. So be careful on that part. Okay, people. So that is about the VNets. Now let's talk about the IP addresses. Okay, because well, we need an IP address. Okay, now that we know about the VNet and the subnets, everything in your environment is going to require an IP address. Why? Well, it's like an on-premises. You need an IP address to the server. You need an IP address to the user. You need an IP address to the voice over IP phone. You need an IP address to whatever. Okay, everything needs an IP address in order to be communicated with your other services, right? So in Azure is exactly the same. Everything needs an IP address. Now, in Azure, okay, you can assign IP addresses to different services, and you can have different types of IP addresses. Okay. First of all, we have public and private IP addresses. Okay, we have public and private IP addresses. So for the public IP address, means this is the IP address that you can use to communicate to the internet. Okay, the public IP address is the one that will connect to the internet, and this IP address can be a basic. Okay, which is the let's say the less expensive. Okay, but it's the most basic allocation. So you have a basic SKU and you have a standard SKU. Okay, what are the differences between them? Well, the basic is good enough to communicate to the internet, but there are some services that they require a standard SKU. So, for example, if you want to have an application gateway or a front door, for example, which are load balancers, you cannot have a basic SKU. Okay, you must have a standard SKU. There are some services that they do not support basic SKU, and when you connect two services together, they must have the same SKU. So, for example, I cannot have. Let me bring here my pen again. For example, I cannot have a virtual machine over here. Okay, this is my VM. I cannot have a basic SKU, okay, for this virtual machine, and then I want to use a load balancer. Okay, and this load balancer, let me put it here, load balancer, and this load balancer to have a standard SKU. Okay, If you want to communicate them, you are not going to be able to do that because this one is using a standard SKU and this one is using a basic SKU. So you you can either have a basic to basic or a standard to standard, okay? But they need to match. And this is just an example. This is the same for everything else, okay? But this is just an example. A virtual machine with a basic IP address, okay, while you have a load balancer with a standard, okay, or a basic IP address. So they must match. That is important. They must match. We're gonna see that later in our example. They must match. Uh, Something important, people, is that in a basic SKU, okay, in a basic SKU, you can use a static or a dynamic allocation. That means that, well, you know that when you have a static IP address, it always use the same IP address, right? So, for example, if I have the 200.18.10. Whatever 25, okay, this one can be a static IP address. So I always use the same IP address. This is the recommended IP address for web applications and those kind of things, right? Or you can have a dynamic IP address. But in a dynamic IP address, when you stop, for example, I stop my server and I restart it again, well, chances are that that IP address is going to change because it's a dynamic one. Okay, so it can change over time, especially when I restart or refresh my services, like my virtual machine, right? So sometimes dynamic is good enough, okay, but in a production environment, you will never use dynamic. You always use a static, right? The standard SKU only supports static, okay? The standard SKU does not support dynamic. So that is one of the differences. If you are working in a lab environment or in a test environment, maybe you want to use dynamic, okay, maybe you want to use dynamic, but in a production environment it will always be static and you normally use standard SKU. That is one of the main differences between the standard and basic. um, that is static and dynamic. And what else let me see. Well, I think that's uh, that is the main thing. Now, talking about public IP address, remember the public IP address is the one that will connect us to the internet, right? So when you are creating your public IP address, guys, you are going to select what type of IP address are you going to use. Okay, it can be an IP4, it can be an IP6, or it can be both. To be honest, I have never used IPv6. Okay, well, I used it a couple of times in a dev and test environment, and I use it only one time IPv6 when I work with direct access. But more than that, I have never used IPv6, and I have never seen someone using IPv6. Yes, Ashish, you have a question?
Yeah, Julio, thanks. Julio, can you go to last slide?
Yes.
Can you explain the second point for both basic SKU and standard SKU? Open by default, NSGs are recommended but optional, but in the standard SKU, it is more secure by default. How it is more secure? I want to understand that.
Ah, okay. This one is more secure because, well, we're gonna see that in the public IP address is going to be protected or supported by Azure, and because because you can use it with, for example, with firewalls and all those kind of things, you can protect them better. In a dynamic one, well, the IP address is going to be changing over time, so it's going to be more difficult to protect it with for example, with a firewall or with some other services that we want to talk about security. So that's why the standard is the preferred one for production environments. Because, well, you can put it, you can assign, for example, a standard IP address to a firewall, okay, or you can assign a standard IP address to a load balancer and then put the load balancer behind the firewall. Mhm. That is one of the main reasons. The,
Okay, but suppose if I take a basic SKU and a static configuration of a public IP, even then I can do. protect it by securing it on the firewall?
Yes, yes, you can. Yes, you can. If you go for a static, yes,
Huh?
you can do it. Mhm.
Where is the difference then between standard and basic SQL as far as this point is concerned?
Yeah, for this one, you may not know, or may not have any differences, but
Okay.
the main thing when you are gonna see the difference is when you deploy other services. Again, like a front door, if you want to deploy a front door and application gateway, they require, okay, it's a must to have a standard SKU, so you cannot use a basic. It's not even available. You're going to see that the basic SKU is not even available. It's grayed out.
Okay. Got it.
Let's say
Thanks.
that you're going to be forced to use a standard SKU in that, in that part.
Okay. 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 Sure.
Yeah.
Thanks.
Okay, but when you are creating the public IP address, first of all, you can choose which IP address you want to use. For example, it can be an IP4. Most of the times, it's going to be IP4. Okay, that the SKU, it can be standard or basic, but as I mentioned, the basic SKU in many cases is going to be grayed out. So even if it is there in the window, it's not going to be available. You cannot click on the basic. It's not going to be available for us to click on that option. Uh, Such as this one. For example, look at this. We have standard selected, and you can see that automatically this part is grayed out. Okay. Why? Because the dynamic is not going to be available because it's not available in the standard SKU. So when you click on the standard, it will automatically select static automatically. You cannot click dynamic. If if we can check the box of basic, then this is going to be enabled, and then we can choose either dynamic or static. Okay, well, exactly the same thing, okay, that we have here. When you create some of the services, that this part, okay, this part is going to be grayed out. Like this one is going to be grayed out, and the standard is going to be selected by default. Like in this case, static is selected by default, is because many services, they do not support basic SKU. That is the main reason of why we are talking about this part. And the other thing that is here is that tier, okay? The tier. Remember that I mentioned there are some things, some services that they require regional support, and some other services they require global support. Okay, and you may say, Julio, why? Well, maybe I can just go crazy and say, okay, I'm going to use both. I'm going to use standard and I'm going to use global, okay? And I'm going to use static, okay? Because that is the more broad option, okay? The broader option. Well, yes, but remember that you are going to pay for what you use, people. So if you go for both, well, this both is going to be more expensive than if you go for IP4, right? And if you go for standard, well, it's more expensive than going for basic. And if you choose regional, sorry, if you use global, well, global is going to be more expensive than regional, right? And if you go for static, it's more expensive than if you use dynamic, right? So you can get crazy and choose both standard, global, static. Yes, you can do that, but that's gonna mean more money that you are gonna pay for it. So if you don't really require, for example, I have seen some customers that they don't have global operation. They have US operation. They work all around the US, right? Well, if this is your case, you have operations all over the US, but you don't have global operations, and by global I mean Europe and Asia. Okay, if you don't have operations in other continents, then it doesn't make sense to go for global because you are just spending more money. Okay, and you don't want that. Regional is good enough, right? So be careful on this part. Regional is all your region and your geopolitical region, plus global is all the globe. Okay, all the globe. And that means a little bit more money for some of you. Mhm. Finally, there's a chance, people, that you can bring your own IP address. This is something new, okay? This is something new. In the past, you were not able to bring your own IP address. Right now, you can do it, okay? If you have your custom IP address prefix, for example, if you are working with an ISP, Internet Solution Partner, or service provider, Internet service provider, well, chances are that you already have your own IP address range and public IP address range. Okay, so especially when you work again with an ISP, you have some assigned IP addresses. Well, you want to use those IP addresses because you are migrating your on premises to the cloud, and you want to keep the same IP address for your web applications, for example. Well, if that is your case, guys, you can uh, you can bring your custom IP address prefixes. Okay, it's not easy. Okay, is something that is new. Okay, and well, there are some restrictions on that part, but it's possible. Okay, so that the good news is that it's possible to bring your own IP address prefixes. That is the good news. Bad news is not that easy, okay? Because well, you need to cover many prerequisites, okay? Not only for Azure, but for your vendor, for your ISP, etc., etc. So there are some considerations, but good news, you can do it, okay? You can now bring your own IP addresses. So that was for public IP address. The other one, okay, the other thing is the private IP address, okay, and the private IP address is like in your own premises, right? So you can create any private IP address and assign it to your users, to your servers. You can have static internal IP address, or you can have a DHCP, okay, a dynamic allocation of IP addresses to your servers and to your users, which is the most common thing, right? That you use a DHCP to have dynamic allocation. So, so people, for the public IP address, you can have dynamic and static, right? And these are the services. Okay, we're going to talk about these services, okay, during this class, but these are the services that supports each of these allocations. For example, look at this. Virtual machines supports both of them. Load balancers, both of them. VPN gateways, we're going to talk about VPN gateways, both of them. But then here are the things that start getting more interesting. The Azure firewall does not support, okay, dynamic allocation for the firewall. The NAT gateway, okay, the NAT gateway does not support dynamic allocation, only static allocation. And application gateway, okay, the application gateway supports static, okay, in the version 2. We're going to talk about application gateway, and dynamic only on version 1, but version 1 is deprecated, well, almost deprecated. So let's say that we don't support dynamic anymore, okay, on the application gateway. So there are some services that they do not support dynamic allocation, only static. And of course, static is the recommended one for production environments. So, guys, before we go to another break, okay, in your exercise, that means in your lab, okay, you are going to create a whole environment. Let me explain you, okay, this environment, and then we're gonna take a break. In your lab environment, you are not right now, okay, not right now, but in the afternoon, in your lab environment, you are going to create three, okay, you're going to create three VNets, okay, the East US, West Europe, and Southeast Asia. These are the three VNets that you are going to create. Look at this. This is the 10.40.0016, 10.20.0016, and 10.30.0016. Okay, these are the three VNets that you are going to create. In each VNet, you are going to create subnets. As you can see, for each VNet, you're going to have different subnets. This has 4 subnets. This one has 4 other subnets. This is the one that I show you. Okay, this is the one that I show you, and this one only contains 1 subnet, right? Why do you want to have all this configuration? Well, because you are going to deploy some virtual machines inside each of these VNets. Okay, well, inside these subnets, you are going to deploy some virtual machines, and you are going to start working with them. Correct. So that's why you want to have these VNets with these subnets. This is what I showed you. Okay, let me go back very quickly here into my lab environment. Well, not my lab, but my environment. So here you can see that I have my core services, okay, which is that 10.20, okay, with the subnets that I showed you I just showed you in the diagram. I also have the manufacturing, which is this manufacturing VNet is the one that is living in Europe. Okay. So you can see that this one is in West Europe, right? You can see that subnet address range is that 10.30. Okay. 10.30 with the subnets which are the subnets that I show you. Well, I even have more subnets. You can see I have more subnets, but these are the subnets that we created or we are going to deploy. And we have the research, which is in Southeast Asia with the 10.40, okay, 10.40, and the subnets that we work. Look at this. I have one subnet for my firewall. This is the default the gateway, okay, and this is my working subnet. So you can see that I have different subnets with different subnet masks in my environment. But we are going to be working, please remember this diagram, because we are going to be working with it during the whole class. Okay, all our class is going to be based on this diagram, so please remember it, because we're going to be working everything around this diagram. Okay, very good. So we are almost done with this part, people. Now we are going to take a small break. Okay, and when we come back from this break, we are gonna keep talking about these things. So let me just give you another break, and this is that before I'm gonna start my virtual machines because I need to show you some things here. So let me just start my VMs. I'm gonna start all of them because I want to show you a couple of things here. Okay. So, while we wait for our virtual machines to start running, okay, let me show you something. Some of these virtual machines, they have a public IP address, and you can see that some of them are static, okay, because even if they are stopped, okay, like in this case, they are stopped, they have a public IP address assigned. This is because they are static IP addresses. Some other, they have dynamic IP addresses, as you can see, because they don't have any public IP address because they were stopped. So when I start my virtual machines, they are going to be assigned, okay, or they are going to receive a public IP address in order to be able to start working with that, right? So this is what I wanted to show you. Now I started my virtual machines. It's going to take a while. Unfortunately, I forgot to do it before, but what I want to show you also here is that, for example, these two VMs, okay, these VMs, they are in one VNet, which is the core services. This one is in the manufacturing, and this one is in the research. So that means that these virtual machines are in East US, the other one is in Europe, the other one is in Asia, correct? Now, what we're going to be working here, people, is that we want to be able to connect and communicate with these virtual machines, right? We want to communicate them independently, and we want to connect them together, all together. We're going to see that part. So, for example, I'm going to refresh this here because now I started my VMs. So look at this. When I refresh this here, my virtual machines are going to be running and they are going to receive a public IP address. Let's see if that's true. There we go. Okay. Now you can see my virtual machines are not running, which is good, right? You can see that one is updating, starting, running, etc., etc. Now, something that I'm going to show you guys is that uh, once we run or once we start running our virtual machines, another thing is that look at this, that of course each of them are going to have a different IP address. Now look at the IP address. This is a public IP address, right? But if I open the virtual machine, you are going to see that the virtual machine also has
Oh, I was on
an
mute. Hey, Julio, good
internal
morning.
IP
How's
address.
it
Look at
doing over
this.
Detroit,
This is the
Michigan? A
private
little
IP
northwest
address,
of
correct?
Detroit, but it's just
This is
easier
the
to use the term Detroit.
10.20.20.4, which is the internal IP address, because this virtual machine is in the VNet. Look at this. Is in the core services VNet in the data subnet. So that's why we are using this IP address internally, right? Now, we are going to be working with this virtual machine. So let me just go ahead and connect to it. Okay, so let me just click here very quickly. I'm going to request access to this VM because, well, they are protected, right? They are not totally open. So let me just request access. And now let me open it from here. Download the RDP. Very good. Keep it. Okay. So let me open this RDP. And here you can see connect. And if let me just sign in here, it's going to ask me for my credentials. If I remember my credentials. You can see that I am not showing you how to deploy virtual machines and such, right? Because that is for another class. So here is no, here is not, we're not going to cover how to connect to the, or well, let me rephrase. Here, we're not going to cover how to deploy virtual machines because that is not our class. Okay, we're going to see how to connect the virtual machines. So this is my first VM. We're going to come back in a moment to this VM, but let me just connect to the other ones. Okay, let me just open the other ones. I'm going to do exactly the same thing to all of them, right? So we can very quickly connect to all the virtual machines. Sorry, I should have done this before, but uh, not big deal. Let me just put this here, keep it, open it. Okay, connect. Let me do this very quickly before we cover the next topic. So it's coming, it's coming. Let me just open the other one. Where's the access? Okay, just 1 second, guys, please. Just 1 second. And the last one, which is this one. Okay. Okay, very good. So why I am opening my virtual machines? Well, because you can see that each of the virtual machines are living or are running uh, in different regions, right? One in the West, East US, another one in Europe, another in Asia. So each of them are in different regions. So what we want to do is we want to connect to those virtual machines to see if they can communicate between each other and to see how can we communicate each other. Okay, so that is why I'm opening these VMs. And just bring this here very quickly. Okay, almost there. VM admin. Okay, here we go. Nice. Okay, so I have now my virtual machines up and running. Let me just take a look on one of them because it's not answering, and maybe I know why. I know why it's not running, but okay. So one of my VMs is not running, but not big deal. Let me just connect to that VM again. VM number 2. Where's my VM number 2? This one. Okay, so just 1 more minute. Okay, now it answers and very good. Now we're going to spend a lot of time inside the virtual machines, right? So sorry because I'm going to be jumping back and forth between the VMs. Okay, sorry about that, but well, uh, that is needed, right, for us to see how to work with all these things. So I'm gonna bring this here, all my VMs. Let me just connect to all of them. Very good. Okay, this is the other one and the last one. Okay, people. So now we are here. Let me use this. Okay. So now we are connected to all of other all of our virtual machines. Okay, we are connected to all of them. How can we know? Okay, and again, this is supposed to be very easy to understand. So what I'm gonna do is I'm gonna open a PowerShell. Okay, very easy here, and I'm gonna type ipconfig. Okay, nothing fancy, but let me show you these, people. Here is the IP address. Okay, this is the IP address. Let me see if I can make this bigger. Properties. Let me make this a little bit bigger. uh, Font. Let's put, okay, I think that's better, right? So you all can see the IP address, right? So here is the IP address 10.20.20.4 with the default gateway. Look at this. This is the default gateway. The default gateway is here by default is the 20.1. Correct? We didn't assign this default gateway. It was assigned automatically by Azure. So this is what I want you to see. And I'm going to do the exact same thing in the other VMs. So we all can easily take a look on what's going on here. So this is my other VM. Let's go here. Let's go here. Properties, font. Sorry, again, I should have done this before, but no big deal. ipconfig. Look at this. This one is that the 20.5. So you can see that these two VMs are running in the same VNet, okay, because they are part of the same VNet 10.2020, but this one is 5. So you can see that this dynamic allocation of IP addresses, internal IP addresses, are automatically assigned, and they both have the same default gateway. Okay, so for example, if I do, if I try to communicate these two VMs with a very good friend ping, okay, look at this. Of course, they are going to be able to reach out to each other, right? Why? Because they are running in the same VNet, okay, and they have the same default gateway. So that's why they can communicate to each other. This is my VM. This is my VM number 2, and this is my VM number 1. So let's take a look. Ping.10.20.20.5. Okay, so you can see they can communicate to each other very good. But what happened to the other VMs? Okay, what happened to this VM this is VM number 3? Okay, what happened to this one? Let's take a look. Let's take a look, and we have here ipconfig. And this one, let me just make this a little bit bigger. Come on. Look at this. This one is not a 10.2020, okay? This is a 10.30, 10.4 with another default gateway, right? It's a different default gateway. So if I run a ping to 10.20.20.4, which is our first virtual machine, nope, there's no communication between them. Why? Because there's no connectivity. Now, if you imagine the diagram that we placed before, we have the first two VMs are in the US. This virtual machine, this VM3, is in Europe, right? And the other one is in Asia. So they cannot communicate. Okay, right now they cannot communicate between each other. Why? Because there's nothing connecting them. So we need to either deploy a VPN or do something to connect these two VNets so they can reach out to each other. Look at this, right? So this is the VM number 3. And the last one, of course, let's do VM number 4, just to have everything here set up. So I'm gonna type ipconfig. Oh, ipconfig config. Easy, very easy. And then let's make this a little bit bigger so we all can take a look at this one. There we go. Nice. Good. Okay, so now people, now we have these 4 virtual machines. Each of them, we saw the private IP address, we saw the default gateway, and of course this one, if we run a ping to the to the first virtual machine, of course they don't have communication. Okay, now before we see how to communicate these virtual machines, let's talk a little bit about DNS. Okay, DNS. Why we want to talk about DNS? Well, because many times we don't want to know, or we don't want to remember numbers, right? Like the IP addresses, we don't want to remember those. We want to remember names, right? That is the main, that is the main thing. Okay, domain name resolution. So in Azure, people, we can have public DNS and we can have private DNS. Okay, we can have both public and private DNS. Why do we need a DNS? Well, because we want to remember the name of the servers and know the IP address of the servers. You know that, okay? We have been working with DNS servers forever and ever, okay? In an Active Directory. In fact, when you deploy an Windows Server Active Directory, it will automatically create a DNS server resolution, right? So in Azure, you can have them both. You can have a public and you can have a private DNS. Okay, both of them. I'm going to show you that in a moment. Why do you want? Why do you need this DNS? Well, because again, you want to use names instead of IP addresses. If it is internally, well, it's for your servers, for your services, right? If it is internally. If it is a public DNS, it's because, well, you don't want to know the public IP address of your web applications, right? You want to type www.microsoft.com and then you want to reach out to that web page, right? You don't want to remember 200.55.30.20, right? That's something that you don't want to remember, and you don't want your users to know what is the public IP address, right? So that's why we need, and that's why we use DNS. DNS delegation, as I mentioned before, you can create your public DNS zone, okay, and then you can write those DNS servers in your domain. So, for example, let's say that you have a domain in GoDaddy, okay? You have or in any other domain service provider. It doesn't matter, right? But let's say that is GoDaddy. So you have your domain in GoDaddy, right? By default, GoDaddy is going to own the DNS servers, right? So he's going to resolve the DNS requests. But if you want, you can create your DNS service in Azure. Then you can write these server names. You can write them in your GoDaddy domain, and then when GoDaddy receives the request to the domain, GoDaddy is gonna forward those requests to your DNS zone in Azure. And here in the DNS zone is where you are going to have your records. Okay. This is going to be your records, like an A record, a CNAME, an MX, a TXT, or whatever other records that you normally have. Okay. This is something, again, this is something that is not new. Okay. We have been working with DNS records in Active Directory in Windows Server, and you may have your DNS in GoDaddy, for example, okay, like your public DNS and your internal DNS, right? And it's very common that you have this public and private DNS. Well, in Azure, you can also have the same thing, okay? You can have a private DNS, right, with a public DNS. So you can have these uh, we don't call it a hybrid environment, but it's a split brain. Okay, we call it a split brain DNS resolution, and that is when you have your DNS register resolving the request or sending them to your Azure. So you can have your Azure public, your Azure zone, and your internal zone. That is the main goal of the DNS. More than that is exactly the same thing that we have been working all the time in terms of DNS. So let me just show you. Let me just show you that part, okay? Instead of just talking about PowerPoints and showing just PowerPoints, let me jump into my environment to show you that part. So here we can type in Azure. I can type DNS. Okay, and look at these people. We have the DNS zones and we have the private DNS zones. Okay, so be careful on this part because they are two different things. The private DNS zones are like your internal. Imagine that is like your Windows Server DNS server. Okay, this is the one that you have with Windows Server. That is the internal one, and the DNS zones alone are the public DNS that you use with your domain with GoDaddy and such. Okay, so for example, if I go to the private DNS zones, I already have one because, well, to save time, okay, because otherwise it takes a while. But you can see I'm going to create a new one. And look at this. It's going to ask you for your subscription, your resource group, okay, the name, whatever. I can say julio.com, okay, it can be any name, okay. It can be any name. In my case, it's going to be julio.com. Okay. The resource group is going to take the resource group of the resource group location is going to take it from the resource group. And that's it. Okay. That's all you need, people. Okay. Julio.com or whatever you want, julio.net or Julio AI or whatever domain. It doesn't matter what is that domain because this is a private. Okay. So like in your Windows server, you can have whatever domain. This is what we normally have, the local dot, for example, local.julio.com, for example, right? So this is the local one. So it doesn't really matter which domain do you type here because it's an internal one. You don't need to own the domain. For example, I can type Microsoft. I can type Microsoft.com. Of course, I don't own this domain, but I can type it. Well, here is a reserved name, so you cannot use it, but it can be any name, okay? It can be any name that you want because you don't need to own that domain because it's an internal one. So I'm gonna type julio.com, okay? Julio.com, there you go. Review and create, and that's it. That's all we need. I can click on create, and now we have our julio.com private domain. Very good. Well, that was easy peasy. But now the interesting part, I'm gonna go back to my domains because again, just to save time, I already have one domain. So let me open that one. And now the important part is once you have your private DNS, okay, the first thing that you need to do is to link, okay, you need to link that DNS with your virtual networks, right? So when you start creating your resources in your virtual networks, those resources are gonna have a name, okay? It's gonna they're gonna have a record, okay, assigned to that service. For example, here you can see that I have the core services and I have the manufacturing. If you remember, this core services is in the East US, this manufacturing is in West Europe. So these two VNets are connected to the DNS zone. So whatever resource or resources we deploy in these VNets, they are gonna be automatically registered in my domain. So if I go back here, look at this. Look at all these records. Okay. For example, here is my VM1. Here is my VM2. Here is my VM3, and so on and so forth. Okay. I have other services deployed here. And I can create, for example, manually, I can create a record set. Okay, I can give this a name. Okay, I'm gonna give this a name, whatever it is. For example, Julio. Okay, It's going to be julio.contoso.com. This is my domain, contoso.com. It's going to be julio.contoso.com, and then I can assign an IP address to it. Okay, it can be an A record, this is an IP4, IP6, a C name, an MX record, whatever other record. Okay, so for example, I can say it's going to be an A record, and I'm going to use the same one, 10.20.20.4, for example. Okay, okay, there we go. Stop. Look at these people. Now I created a pointer record or a record that is going to be called Julio, okay, for that virtual machine, correct? So now if I go back to my virtual machines, so this is virtual machine number 1, which is the one that has here. Let me just show you that I can ping that IP address, which is the VM number 2, or I can say vm2.contoso.com. And look at this. Oh, sorry. I forgot that ping. Ping vm2.contoso.com. There we go. And look at this. The DNS is resolving, or the DNS is finding the IP address, which is the 20.5. And then we are reaching to the virtual machine number 2. Let's take a look on virtual machine number 2. Virtual machine number 2, we can ping VM1, which is the 20.4. That's totally fine. We can ping the vm1.contoso.com, contoso.com, which is going to answer, okay? And we can even ping, guess what? The julio.contoso.com. Oh, come on, contoso.com. There we go, okay? So that is the way that our DNS is resolving or is finding the IP address that we have in our record, right? And is answering the request. Okay. That is for an internal DNS or a private DNS. Okay. Questions so far? Questions about these topics? Can the domain of one subscription be resolved from another subscription? Can private you mean a private DNS, or is just domain?
Julio, I meant private hosted zone domain.
Oh, okay. So here, okay, when you add your virtual network, okay, when you add your virtual network, if, for example, and that is a very good question. I don't have other subscription here. I just have one. But if you know, for example, your subscription ID on the other virtual network, because every network, as you can see here, every network, let me open it, has a subscription ID, right? And they have a virtual network ID. So if you know this virtual network ID, you can copy it from here, okay? And then on your DNS, you can come here and say, for example, I'm gonna open here on my Julio, and I can add, and I say, I know the ID. So instead of choosing the subscription, if I don't see the subscription, I can click on this one, and then I'm gonna type the resource ID. Well, in this case, it's not letting me to do that, but you are gonna put the resource ID, network resource ID, and then and here is not allowing me because I already have it in the other DNS, but that is all you need. Okay, from the other subscription, you bring the network IP address, the network ID. Okay, here you type it here, and then you are going to be able to do it. So the answer is yes, but you need to copy that virtual network ID, and
Thank you.
that virtual network cannot be associated with another DNS. Yep, makes sense. Okay,
Yeah,
so
thanks.
okay, thank you. So now let's go and type the other, because this was the private zone. Okay, this was the private zone. Now let's take a look on the other zone. Let's type here DNS, and now let's take a look on the DNS zones. Okay, these are the public DNS zone, not a private. So we can create here a zone. Let's create a zone here, and we're gonna give this a name. Okay, so it's gonna be my AZ700 public DNS zone. Just to give this a name, okay? Let me see. Oh, okay. So let me type here. Let me see if I have 1 second. Let me see if I have a domain that I can use to show you that part. Just 1 second, please. Uh, 1 second, please. 1 second, please. I'm looking into my GoDaddy to see if I have a domain that I can use to show you that part. So I should have one here. Sign in. And just 1 second. I'm signing into my GoDaddy page or site or portal, whatever you want to call it. Okay, I'm gonna use this one. And I know that you are not watching my screen, but I'm getting there. Okay, so give me 1 second. My products, and then where is my here DNS? Okay. Okay. So look at this. Let me bring this here. So I have this domain, okay? You can see that is on GoDaddy, okay? I'm working in GoDaddy. I have this domain, rockcert.com. Well, it doesn't really matter. You can see that this domain, okay, the DNS records are managed, okay? They are managed by GoDaddy in this case, which is the domain register, right? Why? Because you can see here on the name servers, you can see that we are working with the default, okay, with the default name servers. That is why we are that is why the GoDaddy is gonna answer these requests, right? So let's copy this domain. Let's copy this domain and let's bring it here. So we're gonna type this here. There we go. And we're gonna create. Okay? We're gonna review and create. Nice and sweet. There you go. So we just imagine that you bought this domain in your GoDaddy. Okay, you just bought that domain, and you want Azure to manage to handle, okay, all the records for that domain. So you want to manage everything in Azure, not in GoDaddy, right? So there we go. Now, people, we have our DNS record for that record cert, correct? Easy peasy. Now, how can we start working with that with that domain? All right, because we want to start creating some records. For example, I don't know, let's say www. Okay, and we want to start working with that part. We want to be able to create these records. How can we do that? Well, the way that we're gonna do it is by copying these name servers. Okay, I'm gonna copy this name server number 1. Okay, and then in my GoDaddy, here, I'm gonna change, okay, the name servers. In this case, it is using the default, so I'm gonna change those. Okay, maybe I'm not gonna do it because it's gonna take a while, but and this is but here, look at this. When you click on change name servers, it says GoDaddy name servers, which are the recommended, or you can say, no, I'm going to use my own. Okay. I'm going to use my own servers, and then I'm going to type here. Okay. Look at this. I'm going to type here my servers, my name servers, which are these ones. And then I need to add all of them. Right. So I'm going to bring this here, and then I'm going to type them all. I need to add all, the 4 of them because they are 4. So I need to add the 4 of them. Where is my, okay. So let's add the 4 of them here. Nice and sweet. There we go. Okay. So now, people, now we can click save. Let me do it. Why not? Let me do it. And now, let me see. Let's see. Maybe it's gonna take a little bit longer or something, but save. There we go. Okay. Look at this. Here it says like clicking consent or updating your Yes, verify. Nice. Okay. Well, he's sending me a passcode. Let me do it. Why not? Let's 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 follow the whole flow here, right? Uh, okay, let's type it here. 6. Okay. 64855. Okay, verify. There we go. Okay, and that's it, people. That's all we need. Okay, so now we refresh. Well, it's gonna take a while. It's not immediately, to be honest. Okay, it's not that fast, but now we updated the DNS record. Well, we updated the DNS servers in our domain. So now look at this. We have this domain that is managed by Azure, and look at the DNS records. We don't have any DNS record. Do you remember that we used to have these DNS records, but because we migrated or we changed the domain, the name servers, now, okay, now this domain is going to be managed by Azure, well, by us in Azure. So now we can start creating some records over here. Look at this, right? So now we can start bringing here. I don't know, whatever thing you want. Okay, you can start bringing here whatever you want, and it's gonna answer back to that. Look at this. So for example, if I type, let's say www, okay, and I'm gonna type here 10.4, for example. Maybe it's not going to answer like that, but let's take a look. If I type www.rock, I think it was rockcert, right? rockcert.com, or what was the name? Rockstar. Okay, so let me just is www.rockstarcert.com. www.rockstarcert.com. Okay, so let's wait. Maybe it's gonna come with something. Maybe not. I'm not sure if I have something enabled in that virtual machine, but well, you got the idea, right? So now we can start creating our DNS records, right? Here with our record sets for each of whatever you want. Maybe you have a web application, and then you can point that to this one, right? Let me do this very quickly so I can show you this. Let me start. I think that they all are stopped, but let me just start this one. Why not? Let me see if I have something on this one. And what I'm gonna do is that I'm gonna copy this. I'm gonna copy. I can use the IP address, but I'm gonna use that one. Okay, this one, and then let me just go here. Is this something interesting for you people, or is something that, well, it's like it's not interesting? Maybe we should look at something else. One second. One second. One second. Let me know if this is something that is interesting for you. Otherwise, we can move to the next topic, right? Just one second. Let me just double check is something here very quickly. Very quickly, very quickly. Okay, one sec. And let me delete this one. Yes. Let me point out to let me create here www. Oh, it's already have a dot. Let's do a CNAME. A CNAME. Let's paste this one. Okay. Come on. Come on. Come on. Come on. Okay. There we go. Nice. So look at this. I created a CNAME, okay, for my domain, and I pointed it to a web application that is running in Azure, okay. This is a web application that is running in Azure. So when I just refresh this here, there we go. And after maybe a second or two, we're going to see that www.rockstarcert.com is gonna return an answer with that web application that I'm running in Azure. Okay, so that is the way that you can buy your custom domain or your own domain. Okay, you are gonna register that domain, or you're gonna bring that domain into Azure by renaming or writing these name servers in your domain register, in this case GoDaddy, and then you are gonna bring those, and you can start building your DNS records. Okay, so that is the way it works. Maybe the web application is actually not running. So well, anyways, so I'm not sure if my web application is actually running. So let me just double check here. It was this one, I think. Let me just double check if the web application is actually running. Nope, it's not running. So that's why. Okay, well, but at least you got the idea, right? Maybe right now it's not running. Maybe it's gonna take a little bit longer, but well, you got the idea of how can you bring your domain into into Azure by using the DNS. So we saw how to work with internal DNS, external DNS. Sean, so for these to be reachable from the internet, the resources you put in the zone have to have a public IP address. Yes, yes, they need to have a public IP address, so they are reachable over the internet. So that's correct. And finally, it's working. So let me just refresh this here, and it should be working now. Okay. So yeah, exactly. They need to be reachable over the internet in order for them to work. Okay. Questions, people? Any questions that you may have? Questions. Sometimes it takes a while to populate the the pointers. So maybe that's why it's not answering. It's taking a little bit longer. But anyways. Okay. Any other questions? Tom, something to add? Does what? Does Azure support is there a roadmap to do so? If we configure custom domain in Entra, we'll get verified. Still, we need to public DNS. Yes, about the custom domain. The custom domain is for you to be able to use it, okay, in your web applications. Okay, in this case, what we are registering is the DNS zone. So you need both. Okay, you need both. We haven't. Okay, we haven't registered a custom domain in Entra, but we just registered the public DNS. So our domain that is hosted in GoDaddy is gonna receive the request, is gonna forward them to Azure, and then Azure is gonna resolve them with the corresponding records. So so you need both. Okay. DNS over HTTP. Wolf those supports the DNS over HTTP. DNS over HTTP. I'm not sure, but let me just double check that one. Okay, Wolf, please. Are we covering DNS resolver here, or we already talk about it? Nope. In this case, yes, Azure is gonna support, okay, that DNS scenarios, okay, that you may have, and well, let me see if I have something about DNS resolver. No, I don't think I have anything. Just 1 second. No, I think that's all we have for here. But that is the way, okay? That is the way that you configure this part. So DNS resolver, no, I don't remember having that in my exam. I don't know, Tom, if you remember having DNS resolver in your exam, but I don't think DNS more than remembering that you have private DNS for internal IP addresses and the DNS zone for public requests. I don't think that we have more about DNS in the exam, to be honest.
Yeah, let me double check on the study exam page to see if that's on there, but I don't believe it is.
Yep. Ram, how do we integrate a DNS with Azure VNet? Yeah, very good question. In that case, okay, if you have that scenario, okay, let me just bring here a slide that we have for you. Okay, in this case, look at this. Here you have your VNets and you have your on-premises, right? And you have DNS queries in your on-premises, like in Windows Active Directory. Okay, you have your DNS. Okay, those queries can be forwarded to your Azure DNS. Okay, and then in Azure DNS is where you are gonna resolve them. So in this case, well, again, you can have two ways. You can either forward all your requests to Azure, or you can resolve them on premises for the internal IP addresses, and that's normally the way we work. Okay, again, we can use a split brain. So internal IP addresses, the internal DNS is going to resolve them. Okay, and public or external IP addresses, the Azure DNS is going to resolve them. Okay, so that is the way that you have the two options. One is to resolve internally in your on premises, or you can forward all the requests. You can just forward all the requests to the Azure DNS, and that is going to resolve them here. To be honest, in a best practice, I don't
Where are we
recommend you
at
to do that.
here?
Yeah. Yes, you have a question? Someone unmuted a microphone. Sean, you have a question?
No, sorry, I was talking out loud.
No problem. No problem.
Didn't realize I was unmuted.
No problem. So I don't recommend you to forward all the queries, okay, all the requests to the Azure, because again, it doesn't make sense. Imagine, for example, in my case, that I have 3,000 users internally, okay, it doesn't make sense to send 3,000 requests to Azure just to resolve an internal IP address, right? So it doesn't make sense. So keep it simple. If you have a hybrid environment, resolve your internal queries in your Windows Active Directory, okay? And just forward the public IP address or external IP addresses to Azure. That is going to optimize the performance of your DNS. But that is my recommendation. You can do it whatever you want. Okay, very good. And I think that's it. We are almost ready to the lunch break. What are we missing here? A couple of things that we are missing before we take the lunch break. So we're going to see, when we come back from the lunch break, we're going to see how to connect the VMs, in this case VM 1 and 3, that they are in different regions. Well, 1, 3, and 4, they are in different regions. And we're going to see how to connect them in this module number 1. We're going to see VNet peering, okay? And then Tom is going to talk about a virtual gateway, which is a VPN gateway, okay? So after the lunch break, we are going to start talking about connectivity with VNet peering and virtual gateway. Okay, and we are also going to talk a little bit, not that much, but we're going to talk about routing. Why we don't talk a lot about routing? Well, because we're going to cover the routing tables in the security part, especially when we talk about Azure Firewall. But we're going to see how to work with routing tables. And another interesting part is to work with NAT, okay? The network address translation, which is also an interesting one. We are going to see how to work with NAT in this environment. Okay, so more to come after the lunch break. What are we going to cover after the lunch break? VNet peering. We're going to talk about routing and NAT. Then Tom is going to talk about the virtual network gateway, okay, or VPN gateway. And then we're going to set up the lab environment, and you are going to have some time to start working with the labs. Okay, don't worry if you don't finish the labs today, that you don't need to finish the labs today. We're going to set up the lab environment so you can start working with the labs. The labs are a little bit long, to be honest. Okay, it takes a while to set up everything and be ready to start working with the lab. So don't worry, okay, don't worry about not finishing the labs today. You are going to have more time tomorrow, and you're going to have more time on Wednesday to run your labs. Okay, and you have 6 and right now we're going to talk about another topic, which is the we saw that we have we have 4 virtual machines. 2 of them are in the same virtual network, right? One is in those 2 are in the United States. One is in Europe. One is in Asia. Okay, so we have 4 virtual machines, each of them in different network. Now, what we are going to see is that how can we communicate between them? Okay, and to do that, we are going to see a concept that is called VNet peering. Okay, again, very easy, nothing complicated. VNet peering is a way to communicate between the virtual machines or between the VNets. Okay, not virtual machines only, but all the services that are living or resides in our VNets. Uh, Before having this VNet peering, okay, back in the days when we started working with Azure 13 years ago, because Azure started on the 2010, uh, the only way to communicate two VNets between each other was by using a VPN gateway. Well, we call it VPN gateway. Now it's called it virtual gateway. Okay. And Tom is going to talk about that in the next module. But that was the only way to communicate between two VNets or between anything else. Okay. That was the only chance. Uh, Everything has pros and cons, right? Everything has pros and cons. The problem of using a virtual gateway is that you are going through the internet. You need to go out to the internet and then build the VPN tunnel, right, in order to pass your traffic through that tunnel. Okay, and again, I don't wanna spoil here module number 2, but at the end you are building a VPN tunnel. Now, years after that, I think that it was maybe 5 years, maybe it was five years from now, that Microsoft released this VNet peering. What is the VNet peering? Well, the VNet peering is a way to communicate 2 or more VNets between each other, but using the Microsoft backbone. Okay, that is the main goal, the main reason, and the main benefit of using VNet peering, that you are not going through the internet, but you are using the Microsoft backbone that we have all around the world. If you remember this slide that I brought for you, okay, if you remember this slide, here you can see, well, of course, Bear is not really detailed, but you can see here that we have connectivity all around the world. Okay, using the Atlantic, the Pacific, you can see all the regions are connected. Okay, between them through Microsoft. Okay, not using the internet, but using the Microsoft backbone. So when you use the VNet peering, people, what you are using is Microsoft backbone to connect all your VNets, okay, your virtual networks. Now we have 2 types of, well, to be honest, they are the same, okay? But we call them, okay, we call them in two different ways. We call them a regional VNet, okay, regional VNet peering, or a global VNet peering, okay? In reality, it's the same, and you're gonna build them the same way, okay? So there's no difference between one or the other, but well, we have two different names, okay? One is the regional, the other one is the global. So you need to remember those for your exam, but at the end is the same thing, okay? So again, VNet peering, you use the Azure backbone. You don't go over the internet. You are going through the Microsoft backbone, which is faster, is not public, and well, a lot of other things. But something important, VNet peering is not transitive. Okay? We're going to talk about that in a moment. But VNet peering is not transitive. Now, let me explain you. Well, let me show you how to build this VNet peering. It's very easy. You're gonna see that it's very easy. I'm gonna show you how to build them in an easy way, and then we're gonna discuss a little bit further on this part. So let me jump into my lab environment. Okay, here we are in the lab environment, and now let me just close this here. And well, you can see that this website is not found. Let me just double check here. Okay, and now what I'm gonna do is that I'm gonna let me just double check here on my virtual machines. Give me 1 second. Okay, everything is up and running. Okay, good. So let me show you this. Remember that we said this is our virtual machine number one, right? This is the IP address 20.4. This is VM number one, which is in the East US, okay? VM number. And we saw that we can communicate VM number one, which is the 20.4, with the 20.5, which is VM number two, okay? We saw that they can communicate between them. It can be using the IP address or even using a DNS, okay? A DNS record. We saw that they can communicate between each other. Why? Because they are in the same VNet, okay? So of course, imagine that it's like having two computers connected to the same switch. Of course, they can see each other, okay, because they are going to share the same address space range. But if you have another user in another switch, well, you need to use a patch cord, right, to connect both switches. Does that make sense? It's the same thing that we did in the on-premises, right? So it is the same thing. So if I go to the VM number, if I go to VM number 3, which is this one, okay, this is VM number 3, is the 10.30.10.4, right? And we saw that we throw a ping to the VM number 1, which you can see that is not reachable. Okay, it's not reachable. Let me just throw it again. You can see from VM1 to VM3 we cannot get through. From VM1 to VM4 we cannot get through. So what I'm gonna do is I'm gonna throw that ping, but we are going to add another parameter here. Well, give me 1 second. And what we're going to do is we're going to do a minus t, okay? Minus t, so it's going to keep pinging, okay? It's going to keep pinging from VM3 to VM1. It's going to keep pinging this one, okay? So it's going to show us a lot of timeouts. Let me do the same with VM number 1. VM number 1. There we go. And I'm going to throw a ping to the 10.30.10.4. Okay, you can see that it's not answering. Okay, and now and of course they are not connected between each other. Okay, so right now there's nothing that communicates between them. But now what I'm gonna do is here in my lab environment, we are gonna build that VNet peering. Very easy, pay attention, okay? It's nothing complicated, but there's some important things that we need to discuss, okay? So let me jump into my virtual networks. Oh, something also important, people, is that in the past, when we started working with VNet peering, you must build the VNet peering in both sides. Okay, that was a manual process that you need to build the VNet peering one side and then create the VNet peering in the other side. Right now is not that case, okay? Right now is just one step and that's it. Of course, Azure is going to automate that part and Azure is going to automatically create that VNet peering for you on the other side. But I'm telling you this because back in the days, okay, we need to build that manually. So let me open my VNet, okay? And here on my VNet, you can see that we have an option that says peerings, okay? So let's go ahead and here on the VNet peerings, you can see that there's none, okay? We don't have any VNet peering, so that's why there's no communication between East US and West Europe. We don't have anything connecting both. But now what we're gonna do is we're gonna click on Add, and look at this here. First of all, is the name of your peering. I normally give them a descriptive name. For example, in this case, it's going to be East US to West Europe. Okay. So something that let me know easily, okay, how is this peering about? So East US to West Europe. So that is one way, okay? One way from the US to Europe is one way of communication. Then, do you want to allow access to remote virtual network? Yes, that is what we want to do. You want to allow traffic to remote virtual network? Yes, why not? I want to allow traffic. Yes, I want to allow traffic. Allow traffic forwarded from a remote virtual network. Okay. This one is going to allow gateway transit. We haven't talked about gateways right now. Okay. But this is if you want to route your traffic from one place to the other. Is possible? Yes, it's possible. So we can allow this forwarded traffic. Use remote virtual gateway or route server. Again, if you want to be able to route your traffic and you have a gateway, as we're going to see in module number 2, or you have a route server, you can do it here. Okay, you can check this box. Um, then the name, okay, the name on the peering link name. What is the peering link name? This is the opposite, okay? This is the, let's say, the return, okay? So in my case, the return is going to be West Europe to East US. So let's put it that way. West Europe to East US, okay? So I know that I have one way of communication east to Europe, and I have the other way to communication Europe to East US. Okay, so that way I build a two-way communication. And then here is the important part. If you are using one single subscription, then you can use Resource Manager and pick your subscription and then pick the network that you want to connect with. Remember, we are using the core services is US and we want to connect to Europe. So in this case, I need to pick, okay, my Europe, which is this one, manufacturing West Europe, to communicate with it. Okay. Now, this is because I'm using the same subscription for both VNets. But if you don't use the same subscription, which is normal, okay, in most of the cases you don't use the same subscription, especially when you have East US. Most of the times it's going to be one subscription, and Europe is going to be another subscription. In that case, it's going to be the same thing that we saw before. You're going to choose here. I know my resource ID. And then instead of picking the subscription, you are going to put the resource ID, as you can see here. Okay, you are going to use the resource ID for that VNet that you want to connect with. Okay, this is when you have multiple subscriptions, when your VNets are in different subscriptions. In our case, we are using the same subscription, so I'm going to pick that one, and then I'm going to pick that West Europe. There we go. And then do you want to allow traffic? Yes. Allow traffic? Yes. Allow forwarded traffic? Yes. Okay. It depends on how you want to use this peering. And then easily, you are going to click on Add, and that's all you need. Now, look at this. This one is going to create two peers, okay? It's going to create one peer, which is the East to Europe, and the other peer, which is West to East. So it's the return, correct? So if I look in my core services, which is the East US, you can see that it was created one peering, okay? This is the peering that was created. What is the peer is going to be West, okay? So we're on the East and we are peering with the West. Now, if I look on the west, let me click on manufacturing. If I click on the west, look at this, okay? It automatically creates for us the return, okay? So now we're on the West Europe and is connected to the East US, and you can see that it's connected. So now that it says that it's connected, let's see if that is true, okay? So now, people, if I go to my virtual machine number 1, which I think that I close it. But look at this. This is my virtual machine number 3. And look at this, that it was timing out before the peer was established. Okay, you can see that it was timing out. And then once we establish the communication, now is answering back again. Okay, so let me just close this here. There we go. So now it's answering again, correct? So let me just go to my VM number 1 because for some reason it stopped working. Let me just connect to that one. Just one sec. I think that I closed the connection. Just 1 second. And then maybe it was restarting or something. Yeah, my VM1 is not answering. Okay, but no worries. Okay, for some reason it's kind of but I can do on the VM2. Okay, on VM2 is the same because they are in the same VNet, so I can use this one. Look at this. Okay. Oh, it's 10. It's 10. 10.4. There we go. And now you can see that from VM2, we are able to reach out to VM3, which is the 30.10.4, right? So you can see that it's answering, right? And from VM3, you saw that it was answering the VM1. Well, for some reason it stopped working. So let me just let me ping VM2. So you can see that now both are connected. And not only that, but the DNS also works. Let me just show you. Let me just show you here on my DNS, on my private DNS, which is this one. You can see that we have a record, okay, for VM3, right? VM3, and look at this. This is a record in a different VNet, okay? And now we can ping the VM3 using the DNS record. Before having the peering, it was not possible because there was no communication between the VMs. But now in my VM2, if I just ping VM number 3 dot contoso, oh, contoso.com, then look at this. It's answering, okay? It's answering. And if I go to VM number 3 and in VM number 3, if I ping the VM number 2.contoso.com, there we go, okay? So now you can see that both are communicated, right? Now, very easy. Let me just show you something because this is important for your exam. Okay. So what I want to show you is that now from BM4, which is in Asia. Okay. This is the 40.0.4. Okay. If I ping, let me just ping that 10.30.10.4, which is BM3, is not gonna answer. Of course, is not gonna answer, and I'm gonna ping from BM4 to BM2, okay, and it's not going to answer also. So let's give this a minute. Just 1 second, just 1 second. Okay, and now we're going to do 2025, okay? And you can see that there's no communication between BM4 and any of the other networks. So what I want to show you now, people, is that we are going to, let me see, why is my VM1 not answering? Give me just 1 second. Let me see if my VM1 is now answering. Okay, now it's answering. Maybe it was restarted or something, but – Okay. There we go. Okay. Okay, so now what we're going to do is let's build a communication between VNet 4, which is Asia, between Asia and VNet 3. Okay, so let's take a look on this one. So now this is going to be Asia to Europe. Okay. Oh, Europe, right? And we're going to allow everything. Yeah. And then the return is going to be Europe to Asia, correct? And we're going to pick here, we're going to connect to Europe, right? We're connecting Asia to Europe. So everything looks good. Nice. And there we go. Okay. So now we connected Asia to Europe. So that means that VNet 4, VM4 is going to be able to connect to VM3. Let's take a look. Okay. So here is VM4, and you can see that before it was failing. Okay, here you can see it was failing that ping, and now, okay, and now let's take a look. Let's ping this again. Okay, there we go. Okay, look at this. Now VM number 3 is answering VM number 4. But here is the thing, people. Here's the thing, and this is why we said that it's not transitive. Okay, here is why we said that it's not transitive, because we have communication. We have communication between. Let me use a slide very quickly here, so I can show you that part. So that is why we said that it's not transitive, because if I go here and let me bring my pen very quickly. There you go. Okay. So imagine that this is VM number 4. Oh, VM number 4. This is VM number 3. Okay. So this is Europe. This is Europe. This is Asia. And this is VM number 2 and 1. Also VM number 1 and 2. That they are in East US. Correct. So we connected United States with Europe. We saw that there's communication. We connected Europe to Asia, so that is that we have communication between them. But if we ping, okay, if we try to communicate this is gonna fail. And you're going to say, why? Because we have United States to Europe and we have Asia to Europe. So we should, okay, we should be able to jump through here and then jump through here. Well, that is why we say that is not transitive, okay? You cannot do that. If you want, you can build another tunnel, another peering between Asia and the US, because it is not transitive, okay? So having Europe connected to US and having Europe connected to Asia doesn't mean that Asia and US can communicate between each other. So let's take a look. Let's see if that is true. Okay. So let's go back to the, let me show you. I am in VM number 3. So if I ping the VM number 2, and I'm gonna use the IP. So if I ping VM number 2 is answering. So this is US. And from Europe, if I ping the VM number 4 is answering. So Europe has communication with the United States and with Europe. Okay, this is sorry, United States and Asia. But if I go to VM number 4, which is this one, okay, you can see that United States is not answering, but Europe is answering. And this is because we don't have this transitivity. There's no, it's not transitive, the communication. But what we can do, okay, what we can do very easy is in Asia, okay, in Asia, we can add another peer, which is going to be Asia to East US, okay. Let's allow this, and then East US to Asia. Nice and sweet. Then we pick here the VNet, which is the core services in the US. There we go. Nice. Okay. And now we build a communication between Asia and the US. Okay. So now let's jump into it. Let's go to VM number 4. Okay. And now, Well, maybe it's going to take a while, but now VM number 2 is going to answer because now we build that connection. Okay, so now VM number 4, look at this, VM number 4 now can reach out to VM number 2, and of course we didn't lose the connectivity with Europe. Okay, so now VM number 4, which is in Asia, can communicate with the United States and Europe. Okay? That is the VNet peering. Questions, people? Do we have any questions? In regards to allow traffic to remote network, where would you not select that? Some case where I only need to initiate not reverse, bot bill. But did you create a VPN gateway before creating? Nope. No, Ashish. That is the beauty of this. Okay, we didn't create any VPN gateway. Okay, we just build we just build the VNet peering. That's all we did. Uh, it is possible to set up ACLs for traffic between it's possible to set up. Yes, it's possible, Andy. Yeah, let me see. You can use that as Tom I mentioned. You can use network security groups for that. So yep, you can use ACLs. Very good. Okay, so I can see that Tom answered some of the questions. Yes, Ashish Malik, questions.
Yeah, I wanted to ask you then when is VPN gateway required? If we can directly set up cross-region peering, then in which case VPN gateway will be required?
We're gonna get there. Good
Okay.
question, but we're gonna get there in a moment. Okay.
Okay, sure, no problem.
Hold me that question. Okay,
Okay.
now if I show you people, okay, if I show you this here, instead of using a ping, let's do a tracer. Okay, let's do a tracer to 10.20.20.5. Okay, now look at this. Okay, look at this. This has only one jump. Okay, this has only one jump to reach out directly to the network. Okay, so from VM4, which is in Asia, to BM2, which is in the United States, you have only one jump. Okay, so when we get to the gateway, you are going to see that we have more jumps. Okay, more steps. In this case, it's only one hop. Okay, between because we are using the backbone. So let's say that they are literally connected only with a patch cord, to say it like that. Okay, imagine that you have the two computers connected with a patch cord to the same switch. Right. This is one of the main differences we're going to see with a gateway that is a little bit different on this part. Okay, but this is what I wanted to show you. So now our VMs are connected between each other, but using the VNet peering. We're going to talk about, let me see, allow traffic to remote network. Oh, okay, Michael, to your question, allow traffic to remote network. Here is the important part. Okay, we can use a more complex situation, a more complex environment. And this is when we have a hub spoke configuration. This is what we call a hub spoke. Okay, these ones, this this is the hub net. Okay, this is the hub. Okay, all this is the hub, and this is what we call the spoke. Okay, we have spoke number 1, we have spoke number 2, etc. Okay. And to answer your question, Malik, for example, if you are going to have an on-premises environment, you must deploy a gateway. Here it says a VPN gateway, but it doesn't need to be a VPN gateway. It can be an express route gateway. We're going to talk about VPN gateways and express route gateways in the next modules. But to connect to on-premises or to connect to other clouds, okay, it doesn't need only to be on-premises, but other clouds like AWS or Google Cloud, you must deploy a gateway. Okay, you cannot establish a VNet peering between Azure and your on-premises because your on-premises is not in Azure, or Azure and other clouds. So in that case, you are gonna deploy a gateway. If you are using VNets inside Azure, I don't see why you want to use a gateway. It's better to use a VNet peering. It's better in terms of performance. It's better in terms of security. It's better in terms of management and maintenance. Okay, so if you are using Azure only or everything that is inside Azure, you better use VNet peering. To communicate outside of Azure, you need to have a gateway. Okay, it can be on premises, other clouds, but you need to have a gateway. And here is where you use either a VPN gateway or an express route gateway. Does that answer your question, Malik?
Yes, it does. Thank you.
Good. Yeah, you're very welcome. And here you can see people that you're going to receive all your traffic in the hub, which is the most common configuration, one of the best practices. You're going to receive all the traffic in the hub. And from the hub, you can establish a peering. Okay, let's say from the hub to VNet V, you can establish another peering from the hub to VNet A. But remember, VNet A and B, they are not communicated. Okay, we don't have transitivity. So you cannot communicate A and B by using the hub. Well, you can route the traffic if you want. Okay, you can do that. I mean, use a route server here and route the traffic. You can do it, but there's no native integration or native connectivity between A and B. You can add another peer over here, okay, to communicate A and B. You can do that, but there's no native transitivity between them. Okay, that's important. Is there a cap on how many locations can be paired in Azure? Okay, that's a good question, Ogaga. We can share. There's a link. Let me just take a look on that one. There's a link with that is gonna tell you all the maximum amounts of whatever. In this case, the maximum amounts of VNet peerings is gonna be there. So let me just grab that in a moment, and I can share that with you. Okay. What else? Okay, VPN gateway use encrypt transmission. Okay, yeah, we're gonna talk about the VPN gateways later. Okay, so that is the VNet peering. You see,
Can I ask for clarity on this slide that you just did? I understand this spoke 1 to spoke 2 peering you just did, for example, but you generally wouldn't do that in a hub and spoke, right?
no. You normally don't build this one. I mentioned this if necessary, but you normally don't have like this.
Okay, I just was trying to make
No,
sure I had it in my head.
no. It's just in case you need, for whatever reason, you need to communicate these two. You need to establish another peer because they are not going to communicate between each other unless you route the traffic from here to here to here. But that's another story.
Okay, like a quick question on this. Like we have a networking setup on this hub and spoke. So is there a major reason why the VNet A and the VNet B is not being connected? They have to connect to the hub.
You can have different types of configurations in your network. Again, for example, you said why not communicate A and B with a peer? Well, you can do it. Michael said why you should communicate A and B if it is not needed. Again, there are a bunch of different scenarios and configurations that you may face. Okay, the best practice is that you establish a hub and you receive all the communication, internal and external, in the hub, but if you need to communicate these two VNets between each other, I mean, if you are going to communicate them, is not needed a peer, right? It's not needed a hub. You can go directly. But again, maybe for security reasons, maybe for other type of configurations, you cannot, or you are not allowed to communicate them, and then you need to use a hub. For example, if you have here a firewall or something. Okay, well, you want to route the traffic. You're going to make something that we call a forced tunneling to route the traffic from VNet B, pass through the firewall, and then to VNet A. Maybe VNet B is your front end. Okay, so you're receiving all the requests here from the internet. This is your front end. And you want to pass all the traffic through a firewall just to make sure that everything is clean before you pass that to your SQL, for example, okay, which is the backend, right? So you can communicate them directly, yes, but you want to add an extra step for a firewall or something that that is going to monitor that traffic. Again, we can talk about different scenarios, different configurations, but each client, each environment, each configuration is different. Does that make sense? Okay, now that we talk about routing, okay, let's take a small look into routing. Talking about routing, people, we have, well, Azure is going to manage the routes automatically for you. Okay, we have system routes which are managed by Azure. You have default routes which are managed by Azure, and you can even have custom routes. Okay, why do you want to have custom routes? Again, if you want to route any traffic through a firewall, through something on premises or in the cloud or something like that, you must build a custom route. But by default, all the routes are managed by Azure. Okay, all the system routes and default routes, they are managed by Azure. So, for example, if I go here and I type here route, look at this. Okay, this is one virtual machine, right? We are inside the virtual machine, and here, well, you can see that. Let me see. Oh, I forgot the print route. Print. Oh, print. Man. Okay, so here, look at this. Okay, here we have the active routes, and this is inside the virtual machine. Okay, this is inside the virtual machine, and you can see here that the gateway, right? The interface, because well, this virtual machine has a network interface, correct? It has a network interface, the gateway, okay, and well, the destination, and so on and so forth, right? Look at this, and look at this option on link, right? So there are some things that you're going to use the gateway. Some of them are local here in the inside the virtual machine. Now, these are the routes that lives in the virtual machine. But if I look at the network interface, let's take a look on the network interface here very quickly. And for the network interface, we can see that in Azure. So for example, I can go to my virtual machine. Let's take a look on the virtual machine. I don't know, the Europe, okay? Europe virtual machine. And this virtual machine has a network interface that is linked to it, right? This is the network interface that is linked to that virtual machine. So this is the one that communicates that server to the switch, right? So I'm going to click on the network interface. And in the network interface, we can see here the effective routes, So I'm going to click on this one and look at these people. So we're going to see the source of that route, okay? And well, all of the other things, the hops and such. So let's give this a moment. There we go. So look at this. We have the default. Look at the address prefixes, right? And then, well, the next hop. Look at this part, okay? Look, we didn't add this route, but when we added the VNet peering, it was automatically created from Azure for us. Okay, so we didn't add these routes to the. This is the East US and this is Asia. Okay, remember we are on the Europe. Okay, on the European network. So these two were added automatically, and you can see the next hop is the global VNet peering. And that's why we are able to reach to these VNets through the global peering, okay, and then we can reach that. So these routes were automatically managed. So if I delete the VNet peering between the VNets, then these routes are going to be deleted. Okay, they are going to disappear because I deleted the VNet peering. These are the default routes that they are managed by Azure. And we also have system routes. When you use other services, you don't need to deal with the routes. Okay, Azure is going to automatically manage that for you. Now, talking about routing, you can also have user-defined routes. You can use a route table. Okay, you can create your own route table to force, okay, to forward or redirect the traffic to a specific place. That is what we call, okay, that is what we call a force tunneling. Okay. For example, in this case, you have something in your virtual network, and for whatever reason, okay, you don't want the let's say the virtual machines that you have in your VNet, you don't want them to communicate directly through the internet. You want to send them through I don't know, again, to a firewall, a router, or whatever. You want to make this force tunneling, so you are gonna break that default route or system route. You are gonna break it because you are gonna create a custom route in terms of precedence. Okay, in terms of precedence, people, here, okay, the custom routes, they have more priority, more precedence. Okay, so if you don't have any custom routes, then the it's going to use the system routes and the default routes, right? They're going to use this one. But if when you create a route table, it will automatically take priority or precedence on your environment, on your configuration. That is what we call a force tunneling, and you are able to do that by creating a routing table. Okay, and once you create a routing table, well, you can connect whatever you need. So let me show you. Okay, let me show you how to create a route table. It's nothing complicated. So here on Azure, we're going to type route. Okay, and here is the route table. You can see that we have other things for routing, but in this case, I'm going to choose route table. In the route table, I already have one. Okay, I already have one route table because we use this one for the firewall. But let me show you, okay, when you create a route table, well, to create a route table is very easy. Just click on create, okay? Then you just give this an, well, you pick the resource group, you pick the region, you pick the name, okay? And you specify if you want to propagate the gateway routes. You normally use this one, okay, to propagate the gateway routes, okay? If you say no, then it's on your side, all the maintenance, all everything is on your side, which is a lot of work. So you normally don't want to deal with that. So you want to propagate a route, especially when you use BGP, right? Border Gateway Protocol. Yes, Malik.
Yeah,
Have a question?
currently you are telling if we need to create a route table on a NIC level, or tunneling we need to do on a NIC level. But if I want to do a force tunneling on the subnet level, or
Yeah,
if I want to create a route table for the whole subnet, not on a NIC level, but for subnet level.
you are going to create this route table. This route table is on the VNet level.
On the VNet level. Okay. Okay. Got
Yep.
it.
If you need to create that on the NIC level, then you need to go to the NIC card to do that. But in this case, we are creating a route table to route all the traffic that is coming through the VNet. We want to route it to some other place.
Okay. Got it. Thanks.
Yeah, no worries. Coley, yeah.
So when you pick the option propagate the routes, does it propagate to the region that you pick, or is it global?
Well, a good question. The propagate is gonna take the gateways that you use, that the gateway that you have. For example, if you don't have any gateway at all, then it's gonna be only between Azure, right? If you deploy a VPN gateway or an express route gateway, okay, well, those works with BGP, and then you can propagate your routes in Azure to those gateways, and from those gateways to Azure, right? If you don't pick that option, then you need to manually build your routes, which is a lot of work. So this is if you have a gateway. If you don't have a gateway, again, like a VPN gateway, express route gateway, or even a route server gateway, then you are not going to propagate anything outside Azure. Everything is going to be managed inside Azure.
All right, thank you.
Okay, so now when you create your route table, to create a route table, this is all you have, okay? You give this a name, you propagate your routes, and that's it. But, well, that is to create a resource. Once the resource is created, people, once you create a route table, then, just cancel this, okay? Then you open your route table, and here is the important part, okay? Pay attention on this part, because once you have your route table service or feature created, the next step is to connect this route table to your VNets that you want to route the table. So you want to route the traffic. So here, you're going to pick the subnets. So for example, I'm going to associate this one with my Asia, okay, with my Asia VNet, and you can see that you can use different types of options. For example, my gateway, my research. This is my subnet that I want to use. For example, I'm going to use the research. Okay, this one. Click OK. Nice. So what I'm telling here is I want to connect my route table to this VNet, to this subnet. So all the traffic, okay, all the traffic in that VNet and subnet is going to be routed, okay, using this route table. And then the next step, which is important, is the routes. Okay, the routes. Here is where you can start adding your routes. First of all, you are going to give this a name. Let's say route number 1. Doesn't really matter. And then the destination. Where do you want to forward the traffic? Again, the traffic that is gonna go to the VNet 4. Where do you want to route it? Well, I can use a service tag, and that's why we use tags, okay, because it's easier, or an IP address. I'm going to choose an IP address, and then you need to type the IP address that you want to use. For example, and this is very common. We're going to see that when we deploy a firewall, right? We're gonna say, for example, here, if it is the 0.0.0, okay, /0, which is the internet, right? This is the internet. So all the incoming traffic that is coming from the internet, okay, and this is just an example, I want to redirect that traffic where? And then you can pick, I want to redirect this to a virtual network gateway, okay, like a VPN or express route. I want to send it to a virtual network. I want to forward it to the internet. I want to use a virtual appliance like a firewall, for example, or a route server, right? Or nothing, okay, or do nothing. If you do nothing, then you are going to kill that traffic there, okay. You're going to kill that traffic. It's not going to be forwarded anywhere. It's going to be just there. But for example, we're going to see that in the firewall, for a firewall, you are going to use this one, okay. You're going to say all the incoming traffic from the internet, I want to forward it to a virtual appliance, which is going to be my firewall, and then you're going to type the IP address of your firewall, okay, whatever that IP address is. For example, I know 10.0.0.4, whatever, okay. This is the IP address of my firewall. Then all the traffic is going to go through the firewall, and from the firewall to the subnet that we just selected, well, to the VNet or subnet that we just selected here. That is the way it works. That is a route table. But you can create multiple routes from all over the place, right? Like in my case, that I have the headquarters, I have offices in other cities, I have an MPLS connection with other countries, I have an ADSL connection with other branches or small branches. So you name it. You can have a lot of different routes if you want. Does that make sense? Questions, people? Questions about this route table? We're going to talk about a little bit more about routing, and we're going to see how this routing works when we deploy the Azure firewall, because this is exactly the example that we're going to run. We're going to create this route table, and we're going to create this route for the firewall to redirect all the traffic through the firewall, and we're going to show you how that works. Okay, but that is the way that you create your route table. Again, when you have a route table, this is going to take priority. This is going to take precedence over all of the other routes. Let me just remove all this because I don't want to mess with my environment. Finally, talking about routes, finally, you can deploy a route server. A route server is nothing more than a virtual appliance. Okay, it's just a virtual appliance that you can deploy in Azure. Okay, this works especially when you want to use BGP. Okay, and let's say that you don't have BGP supported in your own premises environment or other places. You don't have something to support BGP, and you want something to support BGP. Okay, in this case, in Azure, you don't need to deploy a route server, because we natively support BGP in almost all our services or all our gateways and such. Okay, so you don't need a route server. When are you gonna deploy a route server? When you don't have something in your environment that supports BGP. Okay, can we create MPLS circuits between VNets? Yes, yes, you can, and that is when we on module number 3 we're going to talk about express route circuits, and that is exactly what you are looking for, El Basal. But hold me that one for module number 3. The answer is yes. Short answer, yes. Okay. Okay, people, the last topic, okay? The last topic that we have for you, and we are still in module number 1, is a long one because we cover a lot of topics on module number 1. But this one is the virtual NAT, okay? Virtual NAT. Because so far, okay, we focus more on the outgoing traffic, right? We focus on the incoming traffic. So coming from the internet into my environment, we talk about VNet peering, we talk about routing, we talk about VNets, all those kind of things. That's cool. But what happened with the outbound traffic? So we have users in our environment that they need to go out, okay, out to the internet, but we don't have too many IP addresses, too many public IP addresses. Most of the times we only have 1 or 2 public IP addresses, and we need to NAT our users, right? We need to NAT our users so they can use only 1 IP address or something like that. Okay. That is the common way to do it, right? So we have only 1 public IP address or an IP prefix. Remember, the IP prefix is when you want to bring your own IP. But let's say we have a public IP address and we have one virtual network or one subnet inside the virtual network that we want this one to reach out, to go out to the internet, right? So how can we do that? Well, to do that, we have a virtual NAT service, okay, that you can create. You can deploy that virtual NAT service in your Azure environment. This is pretty cool because this NAT service is going to help you for the outbound, but also if you initiate a request from a virtual machine, for example, here, it initiates a request out to the internet and it expects an answer. Well, that answer can come through the public IP address, can come through the NAT and reach to the VM that originates that request. Okay. So you can say, wait a minute. You are saying that we can receive requests even using NAT service? The answer is yes, but it's only when a service answers a request that was originated, okay, or initiated from your own premises. Okay, we normally don't use NAT for incoming traffic. We normally don't use NAT for that. Well, we have a source NAT, but that's another story. Okay, but normally the term NAT, network address translation, is for outgoing traffic, but you can receive traffic in your NAT when it is answering a request that was initiated by your internal services. So you can have something like these, people, more complex. We haven't talked about load balancers, but you can have something like this. Okay, you can have a virtual NAT service that is going to use the public IP addresses, and then your virtual machines. Look at this. Forget about this part. Okay, right now don't look at the load balancers because we haven't talked about load balancers, but you can see that one virtual machine can have a public IP address. Like in our case, we are connected using remote desktop to our virtual machines 1 to 4 because we are using the public IP address of each of the virtual networks, sorry, each of the virtual machines. But we can use a virtual NAT to use only one virtual IP address, and that virtual IP address is going to be in common for your VMs. Okay, let's take a look. Okay, let's take a look on that one. This is the last topic of this module, and then we're gonna take a small break in a moment. So let me show you that part. Well, let me close. First of all, let me close because I have a lot of things open here. And let me show you these virtual machines. Where's my mouse? Okay, virtual machines. I'm gonna open another two virtual machines. Okay, so let me open these two VMs. And let me open this VM. First of all, I want you to see that this virtual machine has a public IP address. Okay, look at this 2172.47.2. This is the public IP address of the virtual machine, right? So let's go ahead and connect to this one, to this VM. Let's connect to this VM. Give me 1 second. And let me download the RDP. This is VM number 1, okay? So let's go ahead and open it. Yes, okay. Okay, well, it's connecting to that one. And I'm gonna open also VM number 2. Let me request access to this VM. Okay. So just 1 second. Let me just sign into my virtual machine. There we go. Okay. And let's give this a moment. Okay, 1 second. Yes, Ashish Malik. Go ahead.
Yeah. I wanted to ask if there is any network visualization tool where we can see how the network is being created or how the connectivity is there between the VNets, like some visualization tool within Azure. Is it
Yes,
possible?
yes, we have that, and that is going to be covered on module number 8, which is monitoring.
Oh,
So,
okay.
yep.
Okay.
So yes, we have.
Okay. Thanks.
Yeah, you're
Great.
welcome. Okay, so let me just connect to this one. Yeah, we're going to talk about monitoring and troubleshooting and all those kind of things, but that is going to be a specific module for that. Okay, so hold me that question, please. So, okay, so here is my virtual machine. Again, I want to show you that the public IP address is 2172, etc., etc. Okay, this is the public IP address, okay, of this virtual machine. So I want to show you. I'm gonna open here Internet Explorer, and let me show you this. Let's go to Bing, and let's look for what is my IP. Okay, look at this. Look at the IP address. Okay, this is the public IP address that this virtual machine is using, 20.172.247.2. Okay, this is the individual public IP address that this virtual machine has. Okay. On the other hand, let me open the other virtual machine for you. Okay. And this is another virtual machine. And in this virtual machine, we're gonna go also to bing.com. And I'm gonna say, what is my IP? Okay. And you can see that the IP address of this other virtual machine is 20.172.197.197. So this is another IP address for another virtual machine, correct? So each virtual machine has its own IP address. Okay, that's the idea. Now we want to use NAT, right? We want to use NAT. So for that, people, we are going to type here NAT. And here is where you are going to find the NAT gateway, okay? NAT gateways. So now we're going to click on this one. And I already have one, but let me just show you. If you create a NAT gateway, you're going to pick the resource group. You're going to give this a name, okay? I don't know, like NAT, AZ700, JC, whatever. The region, if you want to have availability, high availability, depending if you're gonna have that high availability, timeout. That's fine. outbound IP. Okay, what is the IP address that you want to use? Okay, and look at this here because I'm selecting here. Well, you can select here availability zone. Is going to ask you to have 2 public IP addresses, right? You can have up to 2 public IP addresses. And then the subnet, which one is the subnet that you want to connect to this NAT gateway? Okay, which one is the VNet? In this case, the VNet, and the subnet. In this case, I'm gonna pick this one, and it's gonna show me the subnets that are available in this VNet. So you can pick only one. For example, if I pick only one subnet, this one is the only one that is gonna be routed through the NAT gateway, while the other ones are going to be ignored, correct? So you can pick one VNet, and if that VNet has multiple subnets, it doesn't matter. For example, let me just pick the West here. I think that it was West Europe. Let's see, West Europe. So in the West Europe, look at this. It's going to show me all the subnets, and I can pick only one if I want. For example, this one, this one is going to be routed to the NAT, while the other ones are not going to be routed to the NAT, correct? Okay, and then you create your NAT, and now people, once you have your NAT, well, the NAT is going to have an outbound IP address. Look at this. This one is the 2121, okay, which this IP address is not used by any of my virtual machines. Remember, my virtual machines are using 172, okay, 172, and the other one is using the 2172. Okay, this one is the 197, and the other one is the 247.2. Okay, so you can see that we are not using that 121, correct? This one IP address is not used by my machines to go out to the internet. Now with my NAT gateway, I'm gonna connect it to my virtual network. So let's pick here the virtual network. And let's pick the subnets that we want to use, right? In this case, the subnets where my virtual machines resides are, I don't remember, but let me just take a look on my virtual machines. Let me just see in which VNet there resides, because I don't remember. Okay, the public. Look at this. My virtual machines are in the public web services. Let me take a look on the other one. Yep. This one is in the shared, okay, in the shared subnet. So they are in the same VNet, but in different subnet. Each virtual machine is in different subnet. Oh, that's good. So let's take a look on my NAT. Let me go back to my NAT. And now I'm gonna add, first of all, I'm gonna add one of them. Okay. So let's pick let's pick the VNet, but I'm gonna choose only one subnet. Let's save it. Only one subnet. So let's take a look, and now look at this. Remember, please remember that the IP address, okay, remember that the IP address that we have on the NAT is 2121, okay, 2121. So let's take a look on our virtual machines. I'm gonna refresh this here. Remember, I'm not gonna refresh. I'm gonna open another one. I want to keep this original one, okay. This was our original IP address. Let's choose here bing.com, and we're gonna say, what is my IP? And look at these people. Now is using the NAT IP address. It's not using the original. That's why I wanted to keep the original. This is the original IP address, but now that we pass this virtual machine through the NAT gateway, now is using the NAT gateway 21121, correct? So now we are not using the public IP address of the virtual machine, but we are forcing the virtual machine to go through the NAT. Okay. In fact, if I say here, if I make a ping to whatever, for example, www.microsoft, well, not tracer, oh, tracer, Microsoft.com. Okay. Well, maybe the Microsoft site is not going to answer that tracer. Yeah, exactly. That's what I thought. Okay. Yes. See? Tracer. Maybe it's not going to answer also. Yeah, maybe it's not going to answer. But well, what I wanted to show you, I was trying to pull the hops, okay, but well, it's not answering. But anyways, so I wanted to show you this virtual machine is using this IP address, while the other virtual machine, people, okay, the other virtual machine that was not connected or not selected, you can see that I'm going to refresh this here. And this is still using the original IP address. Well, its original IP address. Now, to finish my example, what I'm going to do is on my NAT, okay, on my NAT, I'm going to add the other subnet. So let's go and add the other subnet. Okay, I'm going to click on the shared services, which is the other subnet where the other virtual machine resides. I'm going to save it. And now, guess what? Now, I'm going to go back to my VM. I'm going to go to bing.com. And what is my IP? There we go. Oh, it's still working. Well, it may takes a minute to refresh, but it's supposed to show, okay, that 121. Okay, for some reason maybe it's cache or something. Okay, but eventually you are gonna see that is gonna use that IP address of the virtual NAT. Okay, for some reason it's taking a little bit longer for that VM to show. That is the way that you use the NAT. Now, let me show you, okay, because this one, you can see that this virtual machine is actually using the NAT, okay? This virtual machine is using the NAT. Now, let me remove this virtual machine from the NAT. So I'm going to uncheck this box, okay? I'm going to uncheck this box, save it. And now I remove that subnet from the NAT. So when I go back to my VM that it was using the NAT, now I'm going to refresh this here. And again, maybe it's going to take a while because it doesn't refresh that fast. But after a while, okay, what we expect to see is that it's going to return and show that 172. Okay, so let me open an in private. Okay, Bing, bing.com. Oh, no, Bing, no big, bing.com. Okay, what is my IP? There we go. Okay, so now you can see that now it is not using the 121, which is the NAT IP address, but is using its original IP address. Okay, does that make sense? Is that clear for you, for everyone? Let me just double check aquí on number 2. Let me just use an in private window just to finish my example. So bing.com. What is my IP? Okay, and you can see that virtual machine number 2 is using the IP address of the NAT. Okay, while its original was the 197, right? That was the original IP address, but now is using the NAT because on our NAT we have that subnet. Okay, we have that subnet that is connected to the NAT. Whew. Okay, people. So that is all that we have for you. Okay, this is the end of module number 1. So people, we cover a lot. Okay, what we cover on this module? Okay, this was module number 1, and we cover virtual networks. Okay, we talk about virtual networks. We discuss about public IP addresses. Okay, and we show how to work with public IP addresses. We also covered VNet peering. Okay, we covered VNet peering. We saw how to connect all our virtual machines using VNet peering, right? And finally, we discuss about routing. Okay, we saw how to, well, we discussed how to use routing and how to create a route table, and we ended with virtual NAT. Okay, a network address translation, and we saw how to work with NAT. So that is all for module number 1. I know that this was a little bit long, okay, but as you saw, we covered all the basics of virtual networking. In the upcoming modules, we're not going to take that long because now we covered all the basics, and now we can go a little bit faster in terms of the topics, because we don't need to go back to talk about what is an IP address and what is a virtual network, etc. We don't need to go back to that one because we already covered them. In the next modules, okay, you are going to see that we're going to use these terms, these basic terms, to build other solutions. Okay, so questions. Any risk of asymmetric routing using NAT gateway? I don't think about any risk right now, Andy. No, I don't think right now on any risk on my head, because remember, NAT is only for outbound traffic. So, but you can even put a firewall in front of your NAT gateway if you need. So that's another option if you want to have a double protection of your NAT. You can put a firewall in front of your NAT gateway. Good. Okay, people. So that is the end of module number 1. So let's take a small break, okay? Because I know that it was too long. Let's take a small break. We are going to take it's going to be a small 5
environment to on-premise. You got to determine that as well. You'll also have to figure out your on-premise device. You know, does your on-premise VPN device support Azure? That's just a very fundamental thing to make sure of. Generally, they do. Normally, even if it doesn't expressly say it does, it sometimes still does. So that's just up to your device documentation and our documentation to make sure that those all work. So let's talk about what a VPN gateway is then in general. A VPN gateway is a resource that you have to create to establish a connection. When we have our environment, right, we'll say this is our virtual network here. You need to have this VPN gateway device. And this VPN gateway, this is its own resource that is going to allow you to connect to, you know, an on-premise site or something like that. So you need to create a VPN gateway to establish that connection. Again, with peering, we didn't need to make anything. You just kind of tell it to peer and it works. A VPN gateway, you actually have to create a resource for it. But before you actually create this VPN gateway, we need to do something specific. Julio did a great job talking about virtual networks and subnets and all those things. And so to create a VPN gateway, we actually need to create a special virtual network subnet. So when you have your virtual network, you actually will have to go in and create something that we call a gateway subnet. Now, again, we talked about subnets, and this subnet is a little bit special because this subnet has to be called gateway subnet with no spaces in it, and you can't put anything else in there. If you ever want to create a VPN gateway, you have to initially create this gateway subnet, or else you can't put in a gateway. So basically, on the virtual network that you want, you have to choose to create this gateway subnet. And when you name it gateway subnet and you hit create, Azure will know that, well, hey, this person is trying to create a virtual network gateway. And so they're actually going to provision some VMs in the background. You don't deal with those VMs. You don't do anything. They're just for routing tables and things like that. But you need to have this gateway subnet created before you can even create a gateway at all. And so again, in the virtual network that you want to create that connection with, you want to make this connection happen from on-premise into on-premise into the cloud, you would have to say, I want this virtual network to be that connection, to have that connection. And so then you would, in this virtual network, create specifically that gateway subnet. And you'll notice, let me actually jump to my Azure portal here. So I have I think West US 2, I have a virtual network that's in West US right now. If we click in on this, you'll see that right now I just have a default subnet, very basic, very simple, not much going on here. On the top of the screen, you can make a normal subnet, or you can make the gateway subnet. We actually have specifically set off to the side, if you want a gateway subnet, this is the one that you should click. You can't make a gateway device without having this gateway subnet being made. So right now, I couldn't actually put a gateway in this virtual network because I don't have a gateway subnet. And so to create it, I would hit the plus button. You'll see I can't actually change this at all. The name is set as gateway subnet. You can't name anything else that, and you can't put anything else in there either. Now it automatically listed as a /24. I believe technically you can do a 28. I don't think you can do a 29. I think that's too small for a gateway subnet because again, a /29 only has 8 spots. And someone mentioned this earlier, 5 of them are automatically reserved no matter what. I think if you do a /30, then you only get 1. Oh no, you get 0. Yeah, so you can't even do a /30. So we normally recommend that you do it like at minimum a /27. But if you have more space available, then the better, because you're going to be reserving different. It's going to be using different IP addresses for that gateway, especially if you have a gateway that's shared by a express route and a VPN device. So we have this gateway subnet. We choose a subnet address range. This is all the same as creating any standard subnet. The only difference is that you can't choose the name, because when you choose that name, again, specifically gateway subnet, Azure knows we need to specifically add some things in the background here for this gateway that's going to arrive at some point. So basically, to sum that all up, nothing else matters. You just have to create that other subnet, the gateway subnet. Nothing else goes in there. Make sure it's at least a /27, or I guess I don't know if I use the term higher or slower because it's a /27 or /26 or lower, but more space is available. So anyway, so again, that's the first step to create the gateway, is you need to have that gateway subnet available. And now that gateway subnet is available, now we can go and create the virtual network gateway. We have one spun up, but we're going to create another one to kind of show you what that looks like. So I'm going to go ahead and click plus create gateway subnet here. And just like anything in Azure, you have to choose your subscription. You have to choose the name of it, choose the resource group that it's in. That's all pretty standard. So I'll just call this AZ700 West US 2. Very descriptive name there. And I believe I'm attaching this to a gateway I had in West US 2. Again, as with anything networking, and Julio kind of mentioned this, networking is inherently region-based. So you can't attach a gateway that's in East US to a virtual network that's in West US. It's just a virtual network is in a region, and any resource that's attached to that virtual network has to be inside of that region, generally speaking. You'll notice, we're choosing to create a VPN gateway here. You can also use a virtual network gateway to create an express route connection. So we use the same piece of hardware for both types of connections. We use this virtual network gateway resource, but you're going to get different options depending on which radio icon you hit. So right now I'm sticking with a VPN because we're creating a VPN gateway. Again, it goes over the internet, connects to an on-premise device. You also use this exact same resource to create an express route, but we're going to leave that for tomorrow. Now, a very important concept with Azure networking especially, and I think Julio mentioned this as well with his public IP addresses, is this concept of SKUs, right? So a stock keeping unit, a SKU, is very important to determine the features of your gateway. So I'm quickly pulling up the documentation on it so that I have the gateway SKUs. Here we go. So if we take a look at this page here, you can see that there is a whole bunch of different SKUs available for this resource. And actually, I'll put that in the chat window if you're curious about that. So when you create your VPN gateway, you have to determine what features, what capabilities do I want with it. I'll just throw it out there. 95% of the time, if not higher, we don't recommend ever using a basic SKU. Like we really never recommend using a basic SKU because they don't have a lot of features. A lot of them we're getting rid of, honestly. So you really shouldn't use those unless you have a very specific use case for the basic feature. It is the cheapest, but because it doesn't have that many features available. So just be cautioned about that. You'll see in this example, doesn't support OpenVPN or IPv2, very low throughput, doesn't support BGP, doesn't have any zone redundancy, which we'll talk about later. So it's just not an amazing tool to have. But anyway, what does it mean to choose the SKU of your VPN gateway? Basically, you're going to be choosing how many tunnels you can have and what the throughput's going to be, that and like the zone redundancy option. Those are kind of the big options there. So how many tunnels you have means how many connections are being made. Do you want to have this VPN gateway connecting to multiple on-premise sites? Do you maybe have a site in Chicago and in Detroit, and you want both of those to create a VPN tunnel to the same network? Well, that'll go up, that'll be 2 tunnels. Do you want multiple tunnels from the same site? Maybe you have multiple networks you want to connect to the same network in Azure. You could do that too. Every single connection that you make counts as a tunnel, and that counts against that concurrent tunnel count. So a maximum of 30 tunnels, a maximum of 100 tunnels. It depends on what you need. So you're kind of going between that 30 and 100 mark. You also will have to determine the max amount of point-to-site connections, right? Not only virtual networks from on-premise, but from a point-to-site perspective, how many of your users' laptops and tablets and cell phones can be connected at once? If everyone just went remote and everyone's working from home at the same time, maybe only having 250 concurrent isn't going to fly because everyone's connecting at the same time. Maybe you need to bump that up to 500 or 1,000 or 10,000. You are able to move between SKUs as long as they're within the same generation. That's another important concept. So you'll see on the right side, on the left side here, generation 1, you can scale between these. Generation 2, you can scale between these. You can't move between generation 1 and generation 2. Generation 2 is newer, so if you're going right off the bat, probably start with one of those. But you basically can scale between Gen 1 SKUs and Gen 2 SKUs, but not in between those two. Andy's asking, does it only use IPsec? There is an option for SSL, yes. I believe. Oh, sorry. No, so with point to site, you're using OpenVPN, SSTP, or IPv2. So those are the 3 options you have for point to site. Jason, can you move non-AZ to AZ? Yeah, so I think you would have to reconstruct for that one because that's actually going to be a redundancy option. So I'll discuss that in a second about the different redundancy options that we have because that will determine as well how you want to set that up. I believe you can scale between the different AZs. You'd have to actually create a new resource if you're going from a non-AZ to an AZ because you're actually creating potentially multiple public IP addresses there. But I will discuss that in a second though. So anyway, with the SKU, the SKU is going to choose the capabilities of that gateway. And so in the Azure portal, you choose what SKU you want it to be on. So I'm going to choose the generation 2, and maybe I'll choose this gateway 3 here. Ko is asking the difference between AZ and non-AZ. That's basically going to mean an availability zone. So is it highly available or not? So you'll see if I choose if if I choose a non-AZ one, then it's going to basically only be in one zone in Azure. If I choose an AZ, an AZ SKU, it's going to be available in multiple zones in Azure. I do have a slide that'll kind of illustrate that for you. That'll make it a little bit easier to understand. So I'll get on that in just a second here. So I want to make sure we're on the same page with this so far. So I'm going to do a generation 2, and then you'll see that because I had a gateway subnet created in West US, you'll see that it automatically associates with the subnet that we created earlier, which makes it easier to, so it'll actually find that for you and attach it to the subnet. If you didn't have that subnet available, it wouldn't be able to work with it. Now, you need to have a public IP address because that is how your on-premise site is going to connect to your Azure network. So you need to create a public IP address to use. I'll call this one AZ700 West US public IP, and we'll leave that there. The next thing that you'll see is that we have this option called active mode. I'm going to put a pin in that. So we're going to touch on active mode in a second as well, because that one is going to require some illustrations to help understand that. But I'm going to leave that disabled for now. So we choose the gateway type. We choose the VPN type. Oh, for VPN type, you have the option between route-based and policy-based. So if it's policy-based, I think that's kind of an older model. We don't really see a lot of policy-based anymore because that is going to encrypt a packet and send it through the tunnel based on certain policies. Route-based are more dynamic, and they encrypt and decrypt as they kind of go through that tunnel. We kind of use route-based as the standard now for most tools. So if you have an older VPN device, it might require policy-based. That only works with IKV1. So that's kind of on our basic SKU, but again, generally we're going to be using this route-based VPN. So I can go through and hit create, and that's actually going to take a long time. That is one thing to keep in mind. It does take quite a while for a network gateway to be created, up to 30 or 45 minutes sometimes. So I'm going to hit create here. It's not going to create immediately. I already have one spun up because it takes so long. But just something to keep in mind is that it does take a few minutes for it to create. And so at this point, if I'm going to go back to this diagram here, we have this gateway subnet created, and we have the VPN gateway created, right? And that VPN gateway is part of the subnet, which is attached to this virtual network. So we have this VPN gateway device that has been created here. Now, the next thing we have to create is something that we call a local network gateway. So this is kind of like a logical entity. I'm going to type it out. This local network gateway kind of exists next to the VPN gateway. So I'm going to kind of put it out here. And there's kind of a connection between the local network gateway and the VPN gateway. It's not like another resource per se, but it's kind of a logical construction that exists on top of it. And we use that local network gateway to kind of represent the on-premise device. So we have over here our site on-premise, and we have a VPN device here. And this local network gateway is going to be the one communicating with this VPN on-premise. So the local network gateway is going to have, you're going to put in the IP address or the fully qualified domain name of that on-premise device, of that local endpoint. And then you're going to also have you're also going to choose, how it's going to communicate with that on-premise device. So you're not kind of directly putting this VPN's information into the VPN gateway. You're instead creating this local network gateway representation in Azure that's going to be the one representing this VPN device. At some point, you will have to kind of configure your on-premise device. So you're going to create a shared key. You're going to take a look at all of the different VPN devices that we have available. Again, sometimes there's a script that you have to run. From what I've seen, we normally have a pretty good, like a list of VPN devices that we support. So I wouldn't worry too much. And even if we don't officially support it, sometimes if you talk to the manufacturer, they're able to basically they're able to work with it and figure it out. But you do have to make sure that you configure this on-premise VPN device from our documentation. So there's all the you configure the on-prem VPN device, you configure your local network gateway, you configure your gateway subnet, all of these things. And once you have all that said and done, so this is configured properly, you've set up the local network gateway with the proper utilities. Once all that is said and done, you create a shared key, which is shared between these. And after that's all done, then the connection is made. So it's quite a process, and there's a lot of different tools that you have to recognize before you can create a VPN gateway. So if we look at the Azure portal, I'm going to go back to my virtual network gateway. So this is the one that I already created. I already had it spun up because it takes a long time to create these things. You'll see that in here, I can move between the generations. So I can move between 2, 3, 4, and 5. Right now, nothing's connected to this. If I wanted to add a connection, I would go to add here. So actually, I wouldn't go there. I would do my, I could, if I wanted to create a point-to-site connection, I would go into here. We're going to talk about point-to-site in a second here. We have my public IP address here. And then I wanted to make sure that we're set up with the what I'm trying to do here. Oh, I want to talk quickly then at this point about the active mode. So when you create a virtual network gateway, there's actually a couple different instances of that gateway in that resource. So let me bring up this picture. It's a little bit easier to see here. So this might be one instance of a virtual network gateway. There's actually 2 devices that are ready to go as part of that instance, but the default is you just have one active and one on standby. And so the default is you have one public IP address that connects to your on-premise device, and it has a connection with your on-premise device, and traffic is sent back and forth. Now, the reason that we have 2 of them is for redundancy purposes, right? In case something happens to that connection, say that this gateway goes down here. The idea is that the standby one will come back up online and make that connection between your on-premise, so that you're hopefully not losing that much downtime, that much uptime. There is a brief interruption if it's planned maintenance, then the connection is down for 10 or 15 seconds. If it's unplanned, though, if we don't catch it and it just goes down, the connection time to recover is 1 to 3 minutes. And so that is a little bit of downtime that will have to be accounted for in case there's any issues with the Azure environment. And so another option that we offer is using something called active mode. Active just means that instead of one being on standby and one being active, both of them are active at the same time. Now, what that means is that both of these devices will have to have their own public IP address. So public IP2, public IP1. And both of those public IPs will need to be established to your on-premise device. So if you have one on-premise VPN device, you would need to establish that on-prem VPN device to accept 2 incoming connections. And then any traffic would be sent at the same time across both of those connections. This example kind of shows the final version of it. There also is a way where you could just have your, you could have both of these active at the same time. And establish a connection here as well. So there's kind of 3 different ways that you could approach this. The basic active standby, which is just, you have one of the devices making connection there. You could have active with one on-prem VPN device. So again, you're still going to have 2 public IP addresses, but they're connected to one of your on-prem VPN devices, which has to be configured properly. Or for kind of the ultimate availability, you have active, and they both have a connection being sent to multiple on-prem VPN devices. And so again, the goal of this is to prevent issues with downtime, where if there is a case where some of our hardware has an issue and the tunnel's withdrawn, all the traffic will then be routed over to the other tunnel and prevent that from happening. It doesn't cost anymore to have the active enabled. You will have to pay for another public IP address, but just to enable it, there's no extra cost. But traffic will then be routed simultaneously between them. And then if anything happens, that tunnel will be withdrawn in case something happens with that. So again, there's kind of those 3 different versions there, where there's just a basic active standby, there's active where you kind of maintain that one on-prem VPN device, but for the ultimate high availability, you're going to have that 2 on-prem VPN devices that are kind of simultaneously getting connections from that VPN device. Now, this does use 4 tunnels here, right? There's 4 active tunnels happening in this scenario, which will go up against your tunnel count from your SKU. So if your tunnel limit is 10 or 30 or whatever it is, this one VPN device connection is using 4 of them. And so that's something for you to keep in mind when you're setting up your VPN and choosing your SKU. How many of these connections will you have? Even though this is only one set of a VPN and your on-prem VPN, you're still using 4 different connections here. So you have to make sure that you plan properly for that. And then I guess I didn't have a slide for that. I guess what I want to mention, so someone asked a question about availability zones. The idea of the availability zone is, I'm going to pull up my picture here really quickly. I normally use this for virtual machines, but we can use it with this. With availability zones, the idea is that you have your VPN gateway. Where's that image at? I want this image. Sorry, that my image that I like is not here anymore. Okay, well, you would have your VPN gateway basically spread across different data centers in your region. So when we had that example of having it be an Azure, it was a VPN gateway AZ, you would be able to choose if it's going to be spread across your region or not. Let me quickly pull up that image that I want, because I kind of want to illustrate that here. We've had a couple of different changes to our slide deck recently, so I apologize. Okay, I guess I got to use this picture here because it's the smallest one. So the idea is that inside of an Azure region, so West US, for example, there's actually multiple different zones or data centers you can think about it as. And so if you just choose to have a standard VPN gateway, it's going to be deployed into one of these availability zones, which means that if something happens to that availability zone, your VPN gateway will go offline. So it'll by default be deployed into one of these individual places. Again, still within a zone or within a single zone in a region. If you deploy a VPN gateway with that AZ SKU, like you mentioned earlier, that will deploy that VPN gateway into an availability zone, which will basically deploy the gateway across multiple zones. So it'll be deployed, parts of it will be in this zone and this zone and this zone, so that if there is an issue in one of those zones, like some data center issue, some hardware issue, whatever it is, your VPN gateway will still be available. And so the whole point of the availability zone is you pay a little bit more because we're deploying it kind of multiple times, but it will be available across any of those availability zones, so that no matter what happens to any of those zones in Azure in that region, your virtual network gateway is still available to you. So that's the only difference there, is that it just deploys a slightly higher availability when you're discussing those zones. Or when you're deploying to Azure in a region, you can have it available across multiple zones in case there's any issues with that. So those are the steps involved when you're creating a gateway, a virtual network gateway. So we talked about peering. A lot of different steps involved with peer. With peering, there's kind of only one step involved, which is you go to the peering menu, you hit peer, and you're kind of good to go. With a virtual network gateway or VPN gateway, you have to create the gateway subnet, the VPN gateway, configure the local gateway, configure your on-prem VPN device, and then make the connection from there. So there's a lot more steps involved with maintaining a VPN gateway. You have to make sure that your shared key remains the same between your on-prem device and your VPN gateway. You're paying for all the uptime of your VPN gateway and all the traffic that's going across the internet, which you're paying for. So there's a lot more involved with having this. And your traffic is going to be going over the internet still. It will be encrypted, obviously, as per using a VPN gateway, and then it will be, decoded by your VPN device here and then sent into the rest of your traffic. Now, once you do this, that will basically allow your virtual network to communicate just like this network here is right next to it in Azure, right? That's the whole point of having a VPN gateway, is that it enables that connectivity between your on-premise network and your virtual network in Azure. And so any of those devices or resources on-premise are able to communicate with those resources in the cloud to kind of extend that capability there. So what other questions? Any questions about the VPN gateway, what it does for us, or those steps that we have in setting it up? Again, there's a couple steps involved with that, definitely with kind of establishing that VPN gateway, but any questions about the VPN gateway or the SKUs or tools like that? I'm told I have to wait 10 seconds, but I'm not sure I can ever wait that long to go through that. So, all right. So the VPN gateway, right? The site-to-site connection is how we communicate from Azure virtual networks to on-premise virtual networks or other clouds, I guess. So any devices that connect to that network can communicate with devices that are connected to the Azure network as if they're on the same virtual network, right? And that it kind of the communication is enabled through that VPN device. Now, there might be times, right, when we all had to go work from home, or even right now you're working from home in your personal office, like I am right now, where you need to access company resources on a network, but you're not in the office, right? I have an office downtown. I don't want to drive downtown during rush hour to upload my pay stub or whatever it is. I want to be able to connect to it from my comfortable house here. And so that's when we start talking about point to site, right? The whole idea of point to site is that we're connecting individual resources to Azure. Instead of being the whole network is connecting to Azure and any devices from that network are connected to Azure, it's I want to connect my cell phone, there it is, my cell phone to an Azure network. I want to connect my Surface Book 2 or 3, whatever it is, to an Azure network. I want to make sure that this is all working how it should. And so that is a point-to-site connection, is connecting an individual client device to the Azure network using that VPN gateway. And so there's a couple different protocols that we can use with this. We can use OpenVPN, we can use SSTP, or we can use IKEv2. So OpenVPN is this SSL or TLS VPN that can be utilized on really most devices, Android or iOS or Windows or Linux or Mac. We see this being used a lot. It is, an open source VPN, and it can be broadly utilized with a good degree of accessibility and compatibility. We can also choose to use SSTP, which is a Microsoft proprietary one. That one is supported on Windows devices that at least are Windows 7 or higher, which hopefully most people are. I'm not sure anyone's still kicking around on Vista, maybe XP, but even then. This is our TLS-based VPN here. And then the last one we have is IKEv2, which I think is more focused on the Mac devices that we have here. So when you create a point-to-site connection, you'll need to determine, firstly, the protocol that needs to be utilized to encrypt your traffic going across the internet here. And it's going to depend on especially what client devices are being utilized here. Are you trying to connect a wide variety of devices? Is it just your client? Is it just a bunch of Macs? Is it just Windows devices? And go on from there. And so once you determine your protocol that's being used, your OpenVPN, your SSTP, or your IKEv2, you'll need to determine how you authenticate those users. And that's the next important part, is when someone tries to connect to your VPN device with your client device, how do you authenticate who they are and what they're allowed to do? And so we have 3 different ways that we do that as well. The first one is using an Azure certificate. So basically, you generate a trusted root certificate in Azure, or you use a root certificate that is put into Azure, and then you generate from those certificates that need to be installed on every single client device. And so when that client device tries to connect to Azure, that VPN gateway will verify that root certificate is, from that trusted certificate in the cloud. And so that will, again, you need to use a certificate that's given to you by some enterprise solution, or you self-sign it yourself, but you need to make sure that certificate is in the Azure gateway and that all of your client devices have that certificate in it. The next way is Azure Active Directory. I guess I actually probably should say Entra ID. We just renamed it. Well, I guess we didn't just. It was a couple months ago. You might see the name Entra ID pop up. That's Azure Active Directory. Entra ID, Azure Active Directory. We also allow your users to connect using their own credentials. So you have your users and your Entra ID Azure Active Directory account. They go to log into the VPN. They use their standard login for their organization. Now, that does require you to be on OpenVPN and use Windows 10 or higher, and use the native client, the Azure VPN client. This one's kind of nice because you can utilize a lot of the conditional access tools and MFA tools that we have in Azure Active Directory. So making sure that their permissions allow them to connect to this thing, or make sure they're not connecting from a site that they shouldn't be connecting from, using some of the threat intelligence behind it, where they're not trying to log in from a malicious IP address, or they're not using a password that was posted on the dark web. Or there's all these really cool tools we have as part of Entra ID that we can utilize here. But the idea with the native AAD authentication is you need to basically configure your Azure Active Directory client or your tenant to work with it. And then you enable authentication on the gateway, and then you have to basically make sure that they're using the Azure VPN client on their devices. So that one's a little bit simpler, quote unquote, because you're using their login and password that's already part of your organization. They're already logging in using their ID and password, so they know what that is. And you just have to make sure that they're using OpenVPN and they're logging in using that native client. But sometimes we have existing tools that we want to utilize with our logins, and so that's what we kind of have this third one, this AD domain server authentication. And this one is really popular because it allows you to connect using your domain credentials, and it requires you to use a Radius server. Again, this Radius server is a tool that we can use to verify identity and access rights. There's a lot of different third-party ones out there. And so the idea is that the Radius server that you have for login and authentication is